also, oh, there's Cindy. How did you get there? Oh, you're the moderator. Yes, you are.
I thought I was going to wind up at the bottom. I didn't mean to interrupt. I just wanted to be ready.
Yeah, but you're the moderator. So, Cindy, this is quite a thing that you are organizing for the next 4 hours. So I'll be listening, and I'll be. You can reach me if you want, if you need some assistance, but I'll leave it up to you.
Awesome, I appreciate it. Wonderful. Well, for those of you who do not know me, my name is Cindy Cicalese. My pronouns are she, her. I'm based in the United States in Maryland. I am a principal engineer for the Wikimedia Foundation. And for those of you who do know me but haven't seen me for a while, you can probably tell what my pandemic project was my hair. But I am delighted to be here with you for the next 4 hours to facilitate a panel. I've been in a lot of meetings for the last several years where folks have been, yeah, you know, I'd like to use Docker with MediaWiki, or I've been trying to use Docker with MediaWiki, or I've been successful using Docker with MediaWiki, and wanted to talk to others who had similar experiences, to get advice, to share best practices. And this came up a number of times, and I threw out there a few times, you know, a comment about I should really organize a workshop. I should really get some people together. And finally, I actually got a message from Jeffrey Wang, who's one of our speakers today, who's like, yeah, when are you going to organize that workshop? And I'm like, okay, I guess I really need to do it. So that's what I've done. So we've got 12 speakers. And so just to give you a little bit of a sense of what we're going to be doing together for the next 4 hours, and I'm going to share. Let's see if I can do this. I'm going to share this. So this, hopefully you can all see it, is the list of speakers. And so we've got 3 larger presentations, 20 minutes each, that we're going to start with. And actually, if Máté is here, he can go ahead and click to request access. Hello, yay. So if I think you'll have a blue button in the top right-hand corner. If I'm not, yes, there we go. Okay, so I will add you when it's your turn to start speaking. And the rest of the speakers can do that when it's their turn. So we're going to have 3 longer presentations of 20 minutes each. We'll then have a quick 10-minute break to sort of give people a chance to stand up, stretch. We're going to come back for 6 more 10-minute presentations, take another quick break. Then the 3 final presentations, and then I'm going to give a chance for each of the speakers to quickly go around, and especially those who spoke first, and you know, their chance to do a reaction video, I guess, of you know, what they've heard, discuss just briefly. And then we'll take a final break, again, stretch your legs, and come back and have an open Q&A. And I have set up an Etherpad that I am going to share a link to in the chat. So please feel free to join in. I've set it up in, I guess, 4 basic areas. The first is common issues. If people notice that there's something that a lot of people are mentioning that they want to note as a common issue, please put it up there. Areas for collaboration. If you're like watching and you say, wow, you know, Máté and Giuseppe should really talk, which they have many times. But, you know, if you see an area that 2 people could collaborate, make a note there. Questions for speakers, since we have quite a bit to get through. I'm not going to stop for questions during the presentations. So please, as you have questions, note them on the Etherpad, and then we'll come back in the Q&A section at the end and hopefully get to all of those questions. And then at the bottom, I just left an open notes. If anybody wants to just collaboratively work on notes for the session so that we have them for posterity, although we will have the video in the future. But if anybody wants to work on notes, there's an area at the bottom to do that, just for general stuff. So that's the layout. So without further ado, I want to go ahead and get started. So I'm going to add Máté. I'm going to stop sharing. How do I stop sharing? I stopped sharing. Awesome. And then I'm going to leave the stage. Thank you very much, Máté. And hopefully this will just leave the stage.
Thank you, Cindy, for the invitation and for the introduction. I hope that the audio and video and everything is functioning correctly. I tested it, but obviously you never know. So with that, I'm going to share my screen. Yep. All right, so now you should be able to see the presentation. If everything goes well. Cool. All right, so without much further ado, let's jump into right in. I'm going to be your first speaker in this MediaWiki and Docker marathon today, and I'm going to briefly talk about how we have decided to use a Dockerized version of MediaWiki running on Kubernetes here at Fandom. And first, we are going to look at how our MediaWiki setup looked like before we Dockerized it, and why we decided to do that. And then finally, we are going to look at how the Dockerized MediaWiki setup ended up looking like. So previously, before we ended up Dockerizing MediaWiki, we used a fairly standard setup using Apache, HTTPD, and the pre-fork NPM. We had approximately 43 physical machines used as app servers, and there were approximately 239 LXC containers, each hosting Apache HTTPD split between these 43 machines. We all allocated 20 gigabytes of memory per each container, and depending on the size of the actual physical host, we had somewhere between 2 or 10 containers per each host, depending on the exact hardware specifications. For running MediaWiki's background jobs, we had 3 dedicated bare metal servers, and for developers' use, we had LXC containers set up in the development environment, which were effectively acting as virtual machines where each developer could perform their own work. And for MediaWiki's scheduled maintenance scripts, we had system-wide cron jobs on some bare metal hosts, mostly orchestrated by some custom Perl scripts. And of course, this entire infrastructure was managed by Chef. So as you can guess, there were a few concerns with this setup. The main issue why we decided to move away from it was that this kind of setup entailed a dependency on the operations team for almost every simple change. For example, if you wanted to upgrade the patch version of PHP because a new security release came out, or we wanted to update a PHP extension, or just a system library that MediaWiki was depending on, we would have to submit a request to the operations team, and then we would have to coordinate the rollout. We would first have to update a single development machine to verify it there, and then the entire development environment, and then if all went well, staging, and then production. It would be a pretty gradual process. It would take a long time. It would be convoluted, and it wouldn't be generally something that a developer would do, since it required familiarity with Chef and the way we used Chef to configure this environment. We also had a wide variety of hardware differences between the different environments. As you saw, even in the production app servers, we had differently sized machines and correspondingly different configuration for each of them. You can see in this snippet below, this logic was used to calculate the resources to be allocated to Apache based on the physical specifications of the host. This is not the kind of configuration that we like to see. And because of the relatively static nature of this environment, we ended up having to over-provision to make sure that we are prepared for a worst-case scenario. This was especially evident, for example, in the case of job runners. Generally, the MediaWiki job queue is a constant low-overhead process, but sometimes after certain wiki edits, it can become clogged with high-volume jobs, such as refresh links that consume lots of resources. So our jobs cluster had to be ready and prepared to deal with that, even though 99% of the time those resources would be just idle and unused. And the Chef logic also to support all the different environments, production, staging, dev boxes, especially for the development environment. This quickly became complicated, since the development environment had to support not just MediaWiki and PHP, but various different applications such as Node.js that we were developing. And it became very difficult to maintain for the operations team to maintain cookbooks and configuration for all these different runtimes and applications that we wanted to support. So As a result, we decided to migrate our setup to a Docker-centric setup where we use Kubernetes for production and staging environments, and where we use Docker directly for development. So as part of this, we also migrated away from Apache and just Apache workers for PHP execution in favor of Nginx and PHP FPM. And we switched to a setup where we have a multi-version MediaWiki setup with 2 PHP FPM containers per pod. And we also added a number of sidecars to our MediaWiki deployment, such as Jaeger for distributed tracing, Envoy for proxying HTTP calls, and some exporters for exporting metrics from our applications. And development environment, instead of having virtual machines with the runtimes and different applications provisioned and installed, we moved to KVM virtual machines, which just provide a basic Docker environment with Dockerd and Docker Compose. And each host application, including MediaWiki, became responsible for providing a Docker Compose configuration to run the application on the dev box. As a result, there is no need to install app dependencies on this development virtual machine, and it is much easier to manage from an operational standpoint, as it is a very minimal setup. We also could move out secrets from being hosted in a private repository in favor of being injected at runtime into the containers from HashiCorp Vault, which is our secret storage of choice. So as the next step, let's look at the multi-version support in a bit more detail. Since this happened at the time that we decided to upgrade MediaWiki from 1.19 to 1.33, we had to have a setup where where some of our wikis might still be on the old version of MediaWiki, and some of our wikis might be on the new version of MediaWiki. So as a result, we decided to use a service that has effectively mapped wikis to the version of MediaWiki that they were on. And we used an embedded Lua script on the Nginx level to determine the container, the PHP FPM container, to forward the request to, based on the wiki context. We evaluated some other solutions, such as using a service on a higher level, or deciding it on a higher level instead of doing it in Nginx. But given that a request could either come externally or from within the Kubernetes cluster, we decided that this Nginx level solution was the easiest way to ensure that every request gets routed to the correct backend based on the MediaWiki version. The jobs and the jobs cluster was mentioned as a particular pain point, and we ended up using a dedicated Kubernetes deployment for that is separate from the user-facing, from the deployment that is serving user-facing web requests. We use a model where MediaWiki jobs are executed through HTTP requests. Some of you might be familiar with Wikimedia's change propagation service. This is essentially a same paradigm where a job executor dequeues jobs from a message queue, in our case, RabbitMQ queue, and then makes HTTP requests to a job executor deployment to actually execute the jobs. We decided to leverage Kubernetes horizontal pod autoscaling based on CPU utilization for this workload. So the actual number of pods that we use for executing jobs varies between 15 and 45. HPA was a good fit for this kind of workload because, as it was mentioned before, jobs generally use a low amount of resources, except in special cases where certain wiki edits might trigger a slew of CPU-intensive parsing jobs. And so the CPU utilization target was actually a good metric to scale this deployment on. And as a result, we could completely repurpose the over-provisioned bare metal job runners that were previously only usable for jobs and were sitting mostly idle most of the time, which we considered a great win. Another special case that we had to solve was the aforementioned cron jobs when moving to a Dockerized setup. MediaWiki needs various periodic maintenance scripts to power critical user-facing features. A very easy example is update special pages.php. This script needs to be run periodically to make sure that reports such as special vented pages remain up to date and wiki admins can use it to guide their work. In our case, it is a bit special as we need to run these scripts periodically on approximately 20,000 active wikis. We don't run it for all the approximately 260,000 wikis on our platform, as many of these might not have been edited recently, so we only run it on the 20,000 ones that were active in the last 2 weeks. In this case, we had to make a distinction between scripts that required a particular wiki context to be executed in. For example, update special pages.php needs to run for every wiki separately in order to update these reports for every wiki. For these scripts, we implemented a Kubernetes cron job wrapper that just runs and publishes regular MediaWiki jobs for each of the wiki. And then once all the jobs are pushed to the queue, it exists. And then the MediaWiki job implementation that we are using here simply wraps the maintenance script call, and then the job runner just takes care of executing these jobs as they come in. And for scripts that are not tied to a specific wiki but update some global databases or global resources, we just execute them directly as a Kubernetes cron job using the same Docker image that we use for the regular production environment. And as the next step, let's look at how we actually packaged our MediaWiki inside of Docker. We decided to use a base image that is derived from the quote-unquote official PHP image that you can find on Docker Hub. This image just contains the PHP extensions and system library dependencies that we require for MediaWiki. We mirror this base image to our internal registry, so we don't have a dependency on Docker Hub and its infrastructure for our day-to-day operations. This is a trade-off between convenience and security and control. Obviously, if we wanted to maintain our base images completely, we would have a much higher degree of control between what gets included in the image and what security implications this might entail. And I'm sure that Giuseppe will have a lot more to say on this topic. And then based on this base image, we have a multi-stage build where each environment uses a different target stage. The main difference between stages is that for production and staging, we add the MediaWiki code and the localization cache into the image at build time, while for development, we mount both the code and the localization cache as a volume into the container. This makes it much easier to iterate during development, since you don't need to rebuild the image every time that you change the code or rebuild the localization cache. Whereas for production, the deployment is immutable, so it makes sense to add both of these into the image. We also have some future plans to improve our setup. One thing that we would like to enable is automated vulnerability scanning for our images. We are currently in very early stages of this. We are considering the available tools to use, which is either Docker's own scan functionality, which is proprietary, or the Trivy auditing software from Aqua Security. We still need to design the workflow, how this would look like, and who would be responsible for auditing and addressing the results. So this is still very much in the works. Custom base images is also something that we have considered several times. This is a sort of a complicated topic, as truly reproducible Docker image building tools such as NixOS or Bazel end up reinventing many wheels, such as package management. So we still need to determine if we can maintain custom base images in a sustainable manner, and if yes, who would be responsible for providing and updating them. We don't yet have a firm decision on this. As mentioned before, this is a trade-off between security and convenience. And we are also moving towards the single container MediaWiki multi-version handling, which would greatly simplify scaling and rollout of new MediaWiki versions. Right now, with two different containers, the two MediaWiki versions are completely isolated, but it also means that as we roll out the new version of MediaWiki to more and more wikis, we need to increase the resource allocation for the new version and then gradually reduce the resource allocation for the old version. This can be rather painful. So for our next MediaWiki upgrade, we are going to be using a single container setup where that different versions of MediaWiki are mounted in different paths into the same container. And in this case, we shouldn't need to adjust the resources as we switch more and more wikis to the new version. So, and finally, I wanted to share some of our conclusions that we ended up with after concluding this project. The main benefit of this migration was that we massively reduced the workload for the operations team. There is no longer a need to maintain MediaWiki-specific cookbooks and configuration on the chef side to manage PHP, Apache, or deploying MediaWiki itself. And many of the trivial tasks that previously required operations intervention, such as upgrading PHP or scaling up the production deployment, are now doable by developers. And the resource allocation also became a lot simpler. Instead of having different machines with different rules, such as a production app server or a job runner, instead resources can be added to the Kubernetes cluster in a given data center, and then it becomes usable for all of these workloads. So overall, we are quite satisfied with how this thing turned out, and we are looking to improve this further. This actually concludes the first part of my presentation. So I believe now is the time to ask questions. If you have any specific questions or about the details, we can do a deep dive into that particular part.
Actually, we're going to hold questions till the end after all the speakers have gone.
All right.
So cool. Well, thank you very much. That was awesome. And I'm going to give the stage to Giuseppe.
Thank you.
Oops.
Hello. If you can't hear me, please let me know. Things should work out now. Okay, so. Hi, I'm Giuseppe. I'm a long-standing member of the SRE team at the Wikimedia Foundation, and today I want to talk to you about a fundamental question no one of you was asking probably. Do encyclopedias fit in containers, or how we're converting the Wikimedia production environment to run on containers? The answer for now is kind of, but I guess you want to know a little bit more, so I'll go with order. Our plan is to finish the transition of our application layer to Kubernetes. The last step is, of course, the elephant in the room, which is MediaWiki. This is a large project, and everybody had diverging expectation when coming into it. Managers see a clear path forward where we ship fast, we deliver efficiently our software on top of a state-of-the-art distributed execution environment. I had somewhat different expectations, which went from having to drag the project for the perils of navigating in narrow waters to probably the fact that serious trouble could happen, or even that this could be a complete failure. Now, this isn't just my well-known optimism at play. There are several reasons why I was worried, starting from the fact that our MediaWiki installation has 20 years of crude history running on physical hardware, and thus 20 years of technical debt. For now, admittedly, we're still in the process of migrating MediaWiki, but reality has been much better than my expectations. And today I'm gonna kind of complement what Máté just did and talk to you about a bit more in detail about how we build images, what's inside a production MediaWiki pod, and some experiences running in production with Kubernetes. Let's start with how we build MediaWiki images. Now, I didn't choose this image by chance. If you want, OCI images are layered cakes. Only the layers are made of file system snapshots instead of something delicious. As any self-respecting cook, we have our own recipe for producing our quality cakes. And our production line starts with the fact that we self-build our base Debian images. We build these images weekly on our trusted build servers and upload them to our own Docker registry. These images are built with the same tool that's used for the official Debian images. So there's basically no difference apart from the fact that we control them. On top of that, we build software generic images that are also built weekly by the SRE team, where we have, for example, an image for running Node.js applications, one for running PHP applications, one for Python, and so on. These images are built after the base image is built so that we catch up on software updates. As a policy, we try to stick to just installing Debian packages to deploy software inside these basic images, either provided by the distribution or maintained by the SRE team itself. We've created our own Docker building tool called very unimaginatively Docker PKG to manage building and upgrading such images. Finally, the last step, our deployment pipeline can pick up any new commit to a Git repository and rebuild an application-specific image based on one or multiple of the base images, always using the most recent version based on a configuration that the developer has provided as a YAML file inside of their project. Our deployment pipeline is very specific in not allowing anybody to use any recipe that is prepared using third-party ingredients. So no layer involved in building our images that are used for production can come from Docker Hub. This very strict rule is needed, in our opinion, so that we don't depend on third parties besides upstream developers and our distribution for security upgrades. One thing that you will realize very quickly if you try to run a containerized environment is that the IT world moved to using containers, but the complexity of keeping our software up to date and clear from vulnerabilities has been often underestimated. There's plenty of official images that do not perform security updates in a timely manner. By the way, that's not the case of a MediaWiki one. Thankfully, both it and its bases are regularly updated. But if you're running a service in any way exposed to a public internet, you want to be able to react fast when the next Heartbleed, shell shock level vulnerability happens. You want to be able to control your timing to production and not depend on a third party. There are two ways to ensure the security of software running in containers is on par with what would run on physical hardware. And one is you reduce as much as possible the amount of software installed running in a container. And second, you have a solid pipeline that keeps track of dependencies between layers and allows you to rebuild all of your hierarchy of images from the base to the latest ones that run in production with a few commands. We're kind of there, although our traditional lack of resources has made this project take longer than it should have. Now, as I said, our base images, both the distribution images and the software generic ones, are built and published weekly. And the actual production images are built on top of those via our deployment pipeline every time somebody commits to the project. But of course, you need more than a solid process for updates. You also need to keep track of what you're using, of your inventory. So we have created a tiny service called Service Catalog that audits which images exist in our registry, which images are actually used in production, and which have a newer build available. On top of this inventory, another batch process creates, for every image news, a report that gets submitted to Dev Monitor, which is our centralized resource for managing software upgrades. So this is, for example, is the report that you get for a base image from MediaWiki. This is a 1-month-old version. And you can see that there was one package that could be upgraded. Now, in the latest version of the image, of course, this is not a problem anymore. Now, back to fresh cakes. How do we build our MediaWiki image? It's kind of similar to what Fandom is doing, what Máté presented you before. So on top of a base that's Debian Buster, we build both PHP 7.2 and 7.4 images for a fast CGI app server. On top of those, we add a MediaWiki base image that includes additional PHP extensions like Wikidif, Lua Sandbox, Ximmer, and WM Errors. On top of this base image, we bundle all the configuration that is written as PHP files, all the versions of MediaWiki that we run in production, the private settings and the security patches and the localization cache, all in this image. This organization can be probably improved once we've moved away completely from our legacy environment, but as you heard from Máté, there are advantages and disadvantages to both approaches of bundling every version in a multi-version in a single image or not. Any configuration of a behavior of PHP is controlled via environment variables that are managed in Kubernetes, and likewise, we can select a class of MediaWiki configuration based on an environment variable as well. Okay, so this is how the image is done. Let's move to a different topic. How do we run this image in production? The unit of delivery in Kubernetes is a pod, as depicted here. So what's inside of one of our MediaWiki pods? Well, that's kind of similar to what Fandom is doing. We have a FastCGI container running the MediaWiki image that I just described. We have a web server, which in our case is Apache and not Nginx. We use that for your routing and proxying to the PHP image. And then we have some other application layer proxies that allow us to run MediaWiki at web scale as the MencacheD proxy from Facebook MacRouter and a service mesh proxy that acts as an intermediary between MediaWiki and all the other services, which is Envoy. In addition, given metrics are much more important when running Kubernetes, as I'll explain more later, we also include Prometheus exporters for all the software that doesn't have native support. We decided to adopt Helm as a templating packaging deployment system for Kubernetes. This means that we prepare packages called charts that bundle Kubernetes manifest in a bunch of parameterized templates that can later be controlled by using YAML files. Our charts are available at helmcharts.wikimedia.org, and while they're designed to be used by Wikimedia, they should be general enough to be used externally just by changing the parameters. I should stress the fact that at the moment, batteries are definitely not included with these charts, but if we have the resources, our plan is to make these the canonical Helm charts for running MediaWiki, and soon, TM, we'll have a debug development environment set up based on the production MediaWiki chart. Now, if you remember what I told you about our MediaWiki images, it's easy to realize how they can overall amount to several gigabytes of software layers, especially if you consider the amount of localization cache that we need to have. This forced us to search for both an alternative means of distributing the images in production and to find a clever incremental build strategy. Specifically, we build one image, then for the changes to code and a localization cache under a certain size, we build an additional layer as a patch, basically, on top of that, thus optimizing the transfer. Let's say that your patch has just one file that changes. What we will end up distributing to all the nodes will just be a file system layer containing that single file, resulting in much faster deployments. Once the amount of patches goes over a threshold, we rebuild from scratch again. So we don't have in a situation like the one in the photo here with too many layers. This still doesn't solve the problem of shipping, on occasion, several gigabytes of binary data over the network from a Docker registry to potentially hundreds of Kubernetes worker nodes quickly and efficiently, without causing network failures due to band saturation. To this end, we've adopted Dragonfly, which is a peer-to-peer shoe-in replacement for the Docker pool functionality of a Docker daemon. To show you the effect of that using Dragonfly is having for us, I just pulled a couple of images from our monitoring system during the testing that we've done, where we were pulling the MediaWiki images from 70 nodes. And you can see on top, without using Dragonfly, we're peaking at about 70 megabytes per second out of every single registry, while when using Dragonfly, the ones on the bottom, we reduced the network bandwidth coming out of Docker registries by 1 order of magnitude. Not only that, more importantly, the pull process is O1 in time when increasing the number of nodes pulling the image when you're using Dragonfly, while it increases exponentially when you're using it. One important thing that we learned fast when transitioning legacy systems to Kubernetes is that containerizing properly your payloads forces you to pay back a lot of your technical debt. Specifically, today, I want to talk to you about one piece of technical debt that's been bugging me for years and that we're finally got around to tackling, which is shelling out from MediaWiki. As I suppose all of you know, MediaWiki, and specifically various extensions, use the aid of external programs to perform their functions. Now, this means for wikis that anyone can edit, like Wikipedia's, you're opening a direct pipe to pass arbitrary binary input to an external program via a shell, which is more or less the nightmare of any SRE. Because this basically means that any vulnerability in any of these programs would be a way to give away the keys of a castle, as a MediaWiki app server has access to all of our core data. Now, for a long time, we've had various isolation and mitigation techniques that you have seen in core, using FireJail or C groups and namespacing directly to a certain degree of refinement. Sadly, none of these solutions is available when running in a container, because a container is basically a tighter, better done isolation based on the same technologies as well. So, for example, FireJail doesn't work inside of one. So we decided to work on introducing a library in MediaWiki called Shellbox, which not only abstracts the process of calling an external command, but also ensures that it can be called transparently, just with configuration, doing an RPC request to a Shellbox service, which runs just the same library, basically, as PHP code with an entry point, and basically treats the input the same way that it would be if it was running locally to MediaWiki, but it runs in a container that's completely isolated from MediaWiki code, from the passwords and the secrets that MediaWiki can contain. And so it greatly reduces the attack surface. Also, another thing that we've learned along the way is that managing configuration in a mixed environment, like what our MediaWiki production environment is right now, and is going to be for a while, is going to be hard. Basically, you have to keep the configurations in sync between two systems, right? Your traditional configuration management system, in our case Puppet, and Kubernetes. For instance, we have to keep our Apache configurations in sync between between the two systems. To this end, let me present you the example of the web proxy cake. Here, our base images just cover the basic generic fast CGI proxying. From there on, our deployment pipeline builds an image that includes all the static assets from MediaWiki. And then we add via Helm templates the same configuration that we have on legacy systems, building the templates so that the parameterization that works in Puppet also works for Kubernetes. So the data structure that configures our Apache configurations is the same. So when we need to change something, we just need to change some data in that data structure, and it's synced between the two parts. Okay, on to the last part of my talk. Let's finally talk a bit about our experience running Kubernetes in production. As I said, we're still in process of transitioning MediaWiki to Kubernetes, but we've already converted most of the rest of our application layer to run there. And we've learned some lessons that are applicable generally. Let's talk about the good, the bad, and the ugly with running the application layer of a website, of a large website on Kubernetes. Let's start with the good. You get a lot of benefits you get from running on a cloud for free. Failure of an hardware node is handled automatically and pain-free. We have much more flexibility in testing new strategies and dividing traffic more atomically. Let's say, for example, we need a bunch of pods for dealing with an internal API request to Parsoid. Setting that up takes 1 day on Kubernetes versus our previous need for imaging service and rebalancing stuff with care and probably over-provisioning. Or we need more video scaling capacity. That's one deployment away if you're not using an autoscaler. I can't ever stress how important this is for operating large website. Also, without doubt, adopting Kubernetes pushed our developers to deploy more services quicker, to the tune of 5 new services deployments per quarter, basically. This is partly due to the fact that it's now quite easy to add a new service to production, but also that you can test on your computer with production-like software versions much easier. Finally, as we've seen in the Sharebox case, it's harder to take architectural shortcuts when deploying to Kubernetes, which kind of imposes a certain degree of discipline to how we develop software. Okay, now the not so great things. All of what you've used to do when debugging software on legacy systems becomes highly impractical on Kubernetes. There is no SSH to the server tail logs because you probably have hundreds of pods scattered across many nodes. So you need to collect all the logs of any interest in a central collection server. Also, you need good metrics, the ability to see these metrics either globally aggregated or broke down by pod. So that's why, for example, I think it's fundamental to do good metrics gathering. Add to this that your code and your infrastructure are now shipped together in a tighter bundle, which means that you can control independently when things will be deployed. And you need to schedule, for example, a change of name servers around the code deployments. Also, YAML is really a terrible markup language and a worse system for describing infrastructure as code. Anyone who's used Ansible knows that, right? And while we've been building abstractions on top of the Kubernetes YAML manifests like hell, most of this tooling is quite immature and rough around the edges. I'm not even convinced that we're building with right tooling. But finally, the ugly, which is mostly on the side of you should choose boring technology typically, and trust me, Kubernetes doesn't fall in that category. If anything, it keeps you on a constant grind of upgrades. You need to upgrade them at least every year to keep your installation covered by security releases. You need to keep up with a fast-changing environment, and you will need Kubernetes experts on your team. Also, given most tooling, even the commercial solutions have picked at, is basically generation 0, you need to build your own pipeline if you care about your securing your supply chain. Not only that, but most people in the organization will need to learn to use at least at the basic level these new tools, adding to your investment. And finally, if your service wants to store data locally, I still think Kubernetes is not on par and offers no real advantage compared to using real hardware. Summarizing, today I've talked about how the supply chain security is particularly challenging when using containers and that you should build your own to a large extent. I've described the choices and the challenges that we've been encountering with our ongoing move of MediaWiki to Kubernetes, and I've concluded what amounts to a non-answer, if you want, to a question: is Kubernetes worth it? basically for an organization of a size with environment and scale that we have as Wikimedia, which is pretty peculiar, I would say it's a resounding yes. For smaller organizations or one who can run on top of a cloud, I would say that it's probably better to either skip Kubernetes completely or rely on a managed Kubernetes solution offered by your cloud provider. Thank you for your time. I am done, and even questions will come later. I can just stop sharing.
Awesome. Thank you so much. So we are ready for Adam. And there he is. Awesome.
Hello, can you hear me? And you can't hear me. Oh, that's terrible. Good. Hopefully you can also see some slides. Yeah, so I'm mainly going to be looking at, hi, I'm Adam Shorland. I work for Wikimedia Germany, and I'm going to cover 3 topics here, and it's going to be a mixture of things that I do in my work at Wikimedia Germany, but also in my own personal time on side projects and things like that. Those are MediaWiki Docker Dev, MediaWiki CLI, and also a look into some other Kubernetes development environments that we currently have. There's a little bit of a disclaimer here because this is a mixture of my paid work and my unpaid work. So MediaWiki Docker Dev started off during my WMD working time. An experimentation happened after that, which I'll dive into, which was also done during my working time. This MediaWiki CLI tool that I will be covering is owned by the WMF release engineering team, and my port of MediaWiki Docker Dev to that was done in my volunteer time. And also the WB Stack project that I referenced was created in my volunteer time, but this Wikibase as a service thing will be run by Wikimedia Germany in 2021. So now that confusing bit is out of the way. Yeah, so I'm mainly going to be focusing on development environments rather than running things in production, but I will touch on production a little bit towards the end. So in 2017, I accidentally created this hackathon project that turned into a little bit of a development environment called MediaWiki Docker Dev. This is a development environment that focuses around a simple Docker Compose file that is nice and easy for people to get their heads around. And it ended up getting quite a lot of use over the years without actually being touched all that much. Lots of people seem to like it. And a quick overview of what it is. Here are all of the snippets of the Docker Compose file. So it provides lots of services out of the box with a few basic bash commands. You can create this entire setup, install a MediaWiki. You can install multiple MediaWikis. You can add snippets and Docker Compose overrides, and you can throw everything away afterwards. And it's all, it's 167 lines of Docker Compose. This was never intended as a development environment, and as people continue to use it, there were lots of learnings along the way, and that's where the other projects come in. So at some point in the last year, we at Wikimedia Germany had a little initiative to look at development environments and see how we could improve our workflows. I invested a little bit of time looking into MediaWiki Docker Dev and how a next iteration of that could appear. I spent some time writing, a command line interface rather than a big pile of bash scripts, but with the same principles, that it was nice and easy for a developer to look at. It was all just run using Docker Compose, but that it was a bit more friendly than a big pile of bash scripts. So here's the original prototype of this. It's got a very similar set of services that you can run. So you've got MediaWiki, you've got something like phpMyAdmin or Adminer. You've got some various CLI tools such as npm, Compose, and Quibble, all contained within this environment. But there's also this handy CLI interface with help and things. There's part of the tool so that it sort of pulls everything together. And again, the lifecycle can be seen down there in the bottom, which is very similar. You create something, you install a wiki, you can destroy it and throw everything away at the end. Rather than being in a single Docker Compose file, this one was actually created of 12 separate Docker Compose files. And this CLI tool pulls all of those together and runs them as needed. This was just an experiment though, but I quite liked the direction of where this went. So then onto MediaWiki CLI. So the WMF release engineering team, and I think some other folks at the WMF started this tool. It was initially looking at CLI tooling around the Docker Compose file that was in the MediaWiki Git repository. It's written in Golang, and I quite liked the idea of this tool, and the CLI seemed quite nice. And I set about the challenge of porting this experiment of MediaWiki Docker Dev into this tool. And so this now exists, and you can go and find it at this, where's my mouse? I'm not sure, yeah, at this link down here, and you can go and download it today, and it should mostly work. And it's regularly released, it's tested in CI, and multiple paths through the development environment are tested. It has quite a clean interface, which I'll show some pictures of in a second. And it's also quite flexible, but also still at the moment just powered by Docker Compose. So it's fairly easy for anyone that is familiar with Docker and Docker Compose to look at and see what's going on. And this CLI tool also includes things other than the development environment, but I won't really cover those at all in this talk. So over on the right is what this CLI tool looks like. The development environment is hidden under the subcommand Docker, and there's a whole bunch of services again that you can set up. And if you've used any of the other MediaWiki development environments, some of these all look familiar, and there are some that aren't in previous versions of this. For example, Mailhog. So this again is created from 15 separate Docker Compose files, which is orchestrated by some Go CLI code. And it gives a lot more flexibility than any of the other development environments. The lifecycle, again, is very similar. You have a create command, you have an install command, and you can destroy something and throw everything away. And everything is just a simple Docker Compose file. So if there is ever any extra service that needs to be added to this, all it requires is a little bit of Docker Compose snippet to be added to the tool. And you should then get a simple command to also create and plug into the whole system. So some of the other service groups you can see there is, it has event logging, it has Elasticsearch, it has Redis, Memcached, Graph8, statsd, Postgres, SQL with optional replication, and all of these things. Yeah, so this tool comes with a whole bunch of flexibility and features right now. It's a single binary that you download, and it works cross-platform. You can still extend it with custom services in a similar way to how Docker Compose allows you to have override files. You can easily switch between PHP versions. So you could do some development one day on PHP 7.4 and with 2 commands be running in PHP 8 for the next day. You can easily connect Xdebug for remote debugging of these things. For people that are not super familiar with the MediaWiki world, once you download this tool, there's a wizard that guides you through the setup and cloning MediaWiki and selecting ports. And it should not let you make any terrible decisions there. It prompts users to update whenever there are actually updates available, so that people actually stay up to date with their development environments, and you don't end up with people running development environments from a year ago and then wondering why they're broken. As I said before, continuous integration tests cover the whole thing. There's some basic but totally optional automatic configuration of MediaWiki, for example, here. So if you run the Redis service, this configuration will already be added. So Redis will be connected to MediaWiki straight away. And most importantly, I think, is all of the help for this development environment is inline in the command line tool. And there's probably a lot of other things that I forgot, but those were the most prominent ones. So hopefully this GIF is going to work. This is an example of the wizard. So you run the Docker MediaWiki create command. It needs to know which port you're going to end up exposing this whole development environment in. It asks you where you want MediaWiki to be if you've never run this before. It will also go and clone the vector skin for you because you probably want that while doing development. It will also give you the option to clone things from GitHub because GitHub goes faster than Gerrit in most cases. And it'll also give you the option to do a shallow clone. And this is really for a use case of hackathons, for example. This is probably the quickest way to get started with MediaWiki development now, I'd say. It clones all of the code. It runs the appropriate Docker Compose commands, pulling all of these different files together. All of this looks a little bit familiar. And then you would have your MediaWiki running. The setup again for MySQL, all of these commands have a very similar pattern. So Docker MySQL create, it goes and creates some MySQL containers. And to install a MediaWiki, so this just wraps around install.php and update.php, you can pick a database type and you can pick a database name. There is also a default one. And this will go and run all of the things that it needs to run. And again, so this is an abstraction away from some of the MediaWiki things that most developers would end up doing, but this abstraction is explained in the help of all of these commands. Yeah, so this is available in MediaWiki in the CLI page of MediaWiki.org. So what's next? So we have this other project that we're working on at Wikimedia Germany, which is Wikibase as a service. This runs entirely on Kubernetes right now, and it was built that way on purpose. But I'm not going to dive into how this runs on Kubernetes. I think the other two talks were far more informative than I would be able to create a talk for this. But the interesting thing here is the development environment that we've just finished playing around with. So the development environment for us, it all runs on Minikube locally on our machines. It's powered by a collection of Terraform, Helm, and Scaffold. And Scaffold is really part of the nice part of that environment. So the entire development environment from our deployment repository is set up with these few commands. Most of these are hidden in a makefile. Run a Minikube cluster up here at the top. Apply some Terraform definitions and apply a bunch of Helm files. Run a tunnel to Minikube so that you can actually access it locally. And run this tool called Scaffold. And in a few minutes, you'll have the entire cluster set up locally, exactly as it is set up in production, with all of the same images, pods, orchestrated in the same way. And it's just generally very nice. And the key thing at the end here is with development changes visible on top of that. And that's where this thing called Scaffold comes in, which we've only really looked at in the last couple of months, but it is a great tool for local Kubernetes development. It can integrate with tools like Helmfile, which is very nice, and it can rebuild images on the fly, but it can also sync files into deployed containers so that you can make small changes to your UI and see that deployed with your entire application in a very short period of time. Here is another little animation then that I found on the internet somewhere, and here's a little example. So over on the right is the IDE of this application. They're changing the text from hello world to hello scaffold. You can see that the scaffold watch command is detecting the change, either rebuilding the image or syncing the code into the container, and the output of the application is changing. And you can use the same pattern for all of the services to varying degrees. So yeah, final thoughts. This MediaWiki CLI tool is currently at version 0.8.1. The plan is that there'd be a real version 1 at some point in the future. And it's currently used by both engineers at Wikimedia Germany and the Wikimedia Foundation. Not all of them, but some of them. Wikimedia continues to move towards Kubernetes, as we saw earlier, and I'm very excited to see what the future development environment for the Wikimedia Foundation production looks like. Maybe it will include something like this scaffold thing, because I think that really fills in some of the gaps that we've been missing in terms of being able to have a complex development environment that's quite nice. And maybe all of this could be abstracted away and bundled up in a CLI tool such as MediaWiki CLI. And I think that is it.
That's awesome. Those were 3 enormously instructive and wonderful talks. Thank you. A great way to start off our workshop. Thank you. So what we're going to do, and there's applause in the chat, we're going to take a 10-minute break at this point. So we'll come back at 35 after the hour. And we'll get started with the next 6 talks. So see you all in 10 minutes. And don't forget to take a look at the Etherpad, and there's conversation in chat as well. If Gökhan can come click on share, I will edit them. Awesome.
Hello.
Hello, thank you.
Thank you for accepting me. I hope you can hear me well. And let me share my screen. Okay. I hope everybody can see the presentation. And unfortunately, till the end of the presentation, I cannot see anything. So, my name is Gökhan, and I work for Honeywell as a system administrator. And today, I want to talk about our containerization adventure. So, and actually, my presentation has two different parts. One part, I will show you. I'm going to show you some slides, and I will talk about the containers we're using. And another part is I'm going to show you one of those containers. So we'll unbox it together. So actually, we are using containers in our daily businesses every day for many, many different reasons. But I just want to show you the result quickly. Here is the Blue Spice container. It's a well-shaped, green, lovely container. So our use cases are very, very different than each other. For example, for code quality tests, code quality scanners, and those are running every day, every moment. And also we're using the containers for code security scanner, scanning our codes for quality and security for each commit, each deployment, each merge, etc. And also containers can conduct our user acceptance tests. And also for the development environment, some of our projects are directly developing inside of the containers to provide unified, containerized development environment. And at the same time, we have package builders. So we're building our software packages. We are delivering Blue Spice MediaWiki as various formats. For those, we need some unified packaging system. And also for the deployment media, we are deploying containers on our customers' on-premise systems to, again, create a unified system. And those containers are with very different configuration types, like we can deploy custom extensions while building the container. We can modify almost anything in the container. We can deploy single sign-on mechanism like Simple SAML or Kerberos SSO. Also, you can terminate SSL certificates while debooting the containers. So those are highly customizable containers, and you don't have to rebuild the container at all. And also, finally, the Blue Spice Cloud Service is our new cloud service. Actually, it's not so new. It's around for a year, but it's the fundamental part of our cloud services. Let me show you how we are creating that lovely green container from source to doc. Of course, everything starts with git pull or git clone, and we're executing some tests on our codes. And if everything is okay, we are start building our packages with Blue Spice command. And at the end of the process, we are getting new shiny Blue Spice package. But something is missing here, which is the green container. Here it is. Our package goes to the container, so we are basically backing inside of the container image, and we are delivering it to our internal and public registries. These are the normal processes, and probably almost everybody does this. But today I want to talk about one particular Docker image we have, which is open public in Docker Hub, and you can find it to search for Blue Spice free. It's our free edition, and we have a very simple reason to have that image, actually. I'm not going to talk about the technical details so much, but at the end of the presentation, you can also check this Docker Hub image, and also I will share the whole source of this container image. So actually, the first impression is very important. And as a Hello World, we want to touch almost everyone and want to show what we are doing. But for the system requirements or installation process might be a little bit tricky. Therefore, we will need to an environment to easily deploy and easily removable, so anybody can give a chance to see a blue spice. And this is the whole point of this image. But also, this image, again, highly customizable, and it's quite suitable for production. Now, let me jump into my second part of my presentation, and also let me check. Oops. Okay, so here is the left side. There's a web browser, and the right side we have a console here. What I'm going to do, I will just going to deploy this image, and I want to show you what we can do here. But first, I have a, let's say, virtual domain here, which is called Blue Spice Dev Local, and it points out my development system here. And also I have some self-signed web and SSL certificates, which I will going to deploy the container right now. And in this page, in the README page of the Docker container, you can see the each options you have. And that, therefore, this time, I will going to expose whole Blue Spice code outside of the container. And I'm going to create a workspace folder here. Also, I will move my certificates, which are already in this folder, in the workspace folder, because our container can understand the SSL is requested when booting. And I will just start the container, which is just standard Docker run. Docker run. Let's put it in removable. Let's do some tractable. And here is my workspace folder, and the workspace folder should be mounted in the data folder in the container. One environment variable is enough for Blue Spice URL. In my case, it should be HTTPS and Blue Spice dev local. And then only thing that I have to do is name of the image and the version. Okay, I did some mistake. Sorry, it should be the E. Okay, so the installation is started. The installation basically exposed the entire Blue Spice package on my host system or my computer in /workspace folder. And what this container provides us? It provides us an Nginx and PHP FPM, and also Jetty9 for our some web services like PDF export, and the Elasticsearch for Blue Spice extended search, and of course MySQL or MariaDB. It depends on the release, and the Parzoid Node.js service. Currently, we are using the Revon 31, so we need Node.js service. But upcoming release, we'll use Revon 35, and a cron daemon for run jobs, and the memcached for object cache. So the installation has very basic steps. Just installs the Blue Spice MediaWiki and prepare the infrastructure for that. Build the search index, set the file system permissions, and starts the necessary services. At the end of the process, we will have a working environment, I hope. Let's wait for the services, and we got the red response. Oops, okay, something is missing here. I didn't expose the ports, so of course we need to expose the ports here. It's ports 80 and the port 443 for the SSL connection. We have to wait a bit again.
There's also a comment in the chat. Are you missing a slash in the URL after HTTPS? No,
actually, yes. Oh, sorry. Thank you very much. Thank you very much. I'm a bit excited. Sorry about that. I'm a bit nervous. All right. Let me clear up everything again to make clear install. Workspace and www. Okay. So it started again. And let me talk about this image, then we have a bit time with installing. So this image is in our regular release cycle. So this image is updated regularly. And if you expose the code base in your host system, and you don't have to care about the updates, because basically you can delete the container and pull the new image, start again, and the container can understand there is an old installation that will automatically update the code base, and you're not going to lose your data. But if you don't expose the code base, it's kind of throwable system for just demo usage. So it will not going to put anything on your system. You can just start the Spice, see what is it, test it, and if you like it, you can try to install anything else in the workspace or in another folder, or you can just install on premise, whatever you like. Okay, so it's about to finish. Starting the services. Okay. Now we have our working BlueSpice. So according to the documentation, our username is wikisysop and the password is please change me. I will not going to change it right now. Okay, now we have full functional BlueSpice MediaWiki free edition, and we can test it, we can use it. Also, our data will be stored in our host system. And let me turn back to my slides and let me start it again. This is actually our first public Docker image as a company. But like I said, we are using a lot of containers inside of our data job. And if you're interested, please take a look, and any contributions will make me quite happy. And here are the links. I will share the links in the chat afterwards. In the GitHub repo, you can find the Docker files and also other includes, and the Docker Hub. You can download the image and inspect if you like. So thank you very much. My presentation is end. Let me stop sharing. And I think.
Awesome. Thank you.
Yeah,
yes,
right.
It is next. Thank you.
Okay.
That's awesome.
Bye.
Yeah.
Hi everyone.
Hello.
I will share my screen. Yeah, that works. Well, first of all, everyone, thank you for having me. I'm Jesse from Wikibase Solutions, and I will have a brief presentation about how we use Docker, but more about what kind of DevOps tools we use, including Docker. So the DevOps tools we use at Wikibase are Terraform, GitLab, and Kubernetes, and Docker. And we're currently using this system to create development environments and production environments that are alike, which allows our developers to develop on likewise environments to production, which solved quite a hassle which we had before we used these tools. So first of all, we use Terraform to set up our infrastructure. We chose Terraform because it's cloud agnostic, and we have clients that want to deploy on AWS or on Azure or other clouds. The Terraform scripts create the database, the Kubernetes cluster, and our GitLab setup. And then we use our, so we've moved over to GitLab in the past year. Our all our repositories have been moved to GitLab, and we use the pipelines from GitLab to deploy our wikis, and also to have a more integrated GitOps structure. So if we're working on a wiki, we create issues. These issues can be created in a discussion with the client or just by our developers themselves. When they start working on an issue, they will create their own branch to fix this issue. And when the issue is fixed, they will create a merge request. Creating a branch will run the pipeline and create an environment for the developer on which he can work. And this environment is completely separate from all other environments. So the developer can work on its own environment. Then we use Kubernetes to deploy these environments on, and we use some services in our Kubernetes cluster. So we use the Nginx ingress to route the request to the correct environments. We use a cert manager service to provide certificates for the environments. We use the GitLab runner to run our pipelines, and we use an Elastic service deployment for the Elastic Store from Semantic MediaWiki, and also for our own extension WS Search, which provides search via Elasticsearch. And also we deploy our wikis to the Kubernetes cluster. Then how do we use Docker in this? We use Docker images, which are built upon layers, which also other presenters told. So our layers are the Debian base image with PHP installed, then MediaWiki installation for a certain version, so that can already differentiate. Also the PHP version you can change quite easily in this setup. So if you want to run an older PHP version or a newer one, it's easy to change that in this setup, and also MediaWiki versions. So we have clients that run on MediaWiki 1.31 or 1.35, and this whole setup is compatible with both those versions. The next layer is then via Composer, we add extensions in a multi-stage build setup. So the Composer, only the result of the Composer run gets added to the container. And then we add some settings for those extensions or for the wiki itself. We also inject a script which is run at startup, which might run update.php, install.php, or rebuild data, or other scripts which should be run during runtime. Then what Docker provides us to do is give some flexibility to the client in what he gets as a final product. So we can provide a few fully provided environment for the client. So he just gets a wiki which he can use for whatever he wants. We can also deploy by just creating the Docker image and providing the Docker image to the client. A way for the client to do the production environment himself. So we have clients that have their own Kubernetes cluster setup where we don't have access to, and we just provide them with the image which they deploy themselves. We can also comply to clients which have some specific requirements to deploy to AWS via Fargate or EC2, so via ECS. And as I said, we can also just provide a Docker image to the client, which he can then use in whatever setup he wants. So what do those dev environments provide for us? It provides really quick and easy to use dev environments to our developers, which are not always familiar with everything Docker related or server related. A good example is that I've worked for Wikibase now for several years, and I wouldn't know how to create a template in a wiki. And the other way around is that we have developers at Wikibase who wouldn't know what I am doing. So with constructing these quick and easy to use environments, they can focus on their own expertise and don't have to do tedious tasks, which they don't want to. Which is also my second point. The setup provides sort of abstracting layers. So developers at Wikibase which are interested in creating a wiki with a new MediaWiki version or a different PHP version are able to get the knowledge of how to do that. But at every step in the way, there's a layer in which they can say, I accept this layer and will work on the next layer, and that's my expertise, or they will dive deeper into how everything works. So it's flexible in what they will focus on. And Docker provides us a flexible way of providing customers with a wiki and a flexible way of deploying to different cloud environments or client-specific deployments. And that was my very quick and small presentation. I'll stop sharing.
Awesome. Thank you. So we are ready for Jeffrey. Thank you very much.
Hi, good morning. Can everyone hear me?
Yes.
Okay, cool. Let me quickly start sharing. Okay. Yeah, it kind of surprised me because I clicked ask to share and just somebody popped up with me. So, alrighty. Just give me one quick second. Let me make it a little bigger for y'all to see. Alrighty. Let's rock and roll. So yeah, hi everybody. I'm Jeffrey Wang from MyWikis. And over the past several months, I've been working with WikiWorks and Wikitech to develop a way for the MediaWiki community to easily run MediaWiki and its components. So today I'll give an introduction of Project Canasta, which aims to solve that. So first, I want to give a bit of historical context behind this project. The project was started in late 2020 by Jeroen Karen with 4 goals: making it easy to set up and configure MediaWiki with various extensions and skins, making it easy to run the entire supporting stack, providing for easy ways to share pages between wikis, and making starter page packages for various wiki use cases. There were ideas floated on whether to use Docker, Ansible, or something else. So in May of this year, we formalized the basis of Canasta at the Enterprise MediaWiki Hackathon in Dallas, Texas. We decided to use Docker with support for Docker Compose and Kubernetes. We decided on over 100 extensions that we thought were relevant, well-maintained, and vouchable to be included with Canasta. Last but not least, we architected how the image would be designed to achieve the project's goals. So since then, we've developed a first iteration of the stack, including the web app image, and it's currently being used with some WikiWorks and Wikitech clients. Our goal is to release a stable version to the general public in the near future. So next, a bit of background behind what problems Canasta is trying to solve. So we all love MediaWiki for its power and its versatility, but allowing MediaWiki to live up to its full potential is very time-consuming and often requires a good bit of expertise. So it ends up being very challenging for non-MediaWiki experts to start up and maintain their MediaWiki instances, and we want to solve that. A few pitfalls of installing MediaWiki that we commonly know include the need to configure short URLs manually, needing to research and download extensions manually and one by one, not having an automatic job queue runner, no Cirrus search by default, and an upgrade process that can get messy due to configuration drift and a directory structure that mixes configuration with source code. So the way we've designed Canasta aims to resolve these pitfalls. So throughout this year, we've refined our goals of Canasta to be the following. 1, it should be easy for a sysadmin to set up, configure, upgrade, and maintain. 2, everything should already be present in the image for installation. 3, we should be as backwards compatible with regular vanilla MediaWiki as possible and try our hardest not to drift away from it. 4, Canasta should be stable enough for enterprise and organizational usage, so we will primarily support long-term support releases of MediaWiki, and in the short term, we will only support LTS releases. 5, sysadmins can use as much or as little of Canasta's feature set as possible. They don't have to install any extensions, or they can use all of them. They can use our convenience features. They can also choose to stick with just core MediaWiki features. 6, Canasta should be flexible enough to allow developers to modify and produce their own aftermarket derivative Canasta images, which become important for specific use cases, and also for just working with perhaps other different tools, such as maybe the ones that we've shown today. And being able to work with these and integrate them together is definitely a possibility with Canasta through this. And 7, the Canasta stack's configuration can be stored in source control and can be split from the code that powers Canasta. The Canasta stack itself is comprised of the web application running MediaWiki on Debian, Apache, and PHP, and we call this the Canasta image. It includes a job queue runner inside, maintenance script runner, transcoder, automated database backups, and over 100 bundled extensions. The supporting stack components like MySQL and Elasticsearch work out of the box with the Canasta image. The stack can be ran on either Docker Compose or Kubernetes. So one of the biggest benefits of Canasta is the bundled extensions and skins. Updates to the extensions and skins will come periodically with new releases of Canasta, which ensures that they are stable enough to not break wikis on upgrade while also keeping extensions relatively up to date. If you want to update them by yourself and use your own version, or if you want to add additional non-bundled extensions and skins, you can do that too, the same way you would do it from vanilla MediaWiki. Bundled extensions are loaded with a slightly different syntax, so you know whether you're loading an extension that's bundled or custom. Last but not least, Canasta aims to support local settings without any special additions needed. So that means you can drag and drop your existing local settings.php to Canasta, and all you would need to change would be the database settings. And we'll have 2 options for loading settings. One via the file itself, just regular local settings.php, and one via a local settings.php.d directory. I want to talk about the impact that Canasta will have on sysadmins who decide to use it. Canasta brings many benefits to the table. So thanks to its use of Docker, it's quick to set up, doesn't require much maintenance, offers a lot of built-in features, eliminates configuration drift, scales easily, and it's easy to be compatible with future versions of MediaWiki. When taking a look at how using Canasta is different from using vanilla MediaWiki, it's easy to see why Canasta supercharges MediaWiki. Setting up MediaWiki is as simple as installing Docker, downloading the Canasta stack, and using one Docker Compose command to start everything. You don't need to configure Apache, MySQL, or Elasticsearch. They work out of the box. And I'm not exaggerating either, because I just did that yesterday, and it was really fast and easy. Upgrading MediaWiki couldn't be easier. The next time you pull up the latest Canasta image, it automatically runs the newer version of MediaWiki upon container startup. Adding and enabling an extension or skin is super easy for bundled ones. You just have to use the CF load functions. If it isn't bundled, then it's just the same process as regular MediaWiki. Use WF load extensions and place it in the folder, and you're good to go. Database backups are tedious and annoying in general, and I don't know anyone who likes doing them, but you need to do them, right? So Canasta automates that process so you can get nightly backups made. Load balancing with Canasta is going to be made easy with the ability coming soon to spin up multiple replicas of the web app. You can take advantage of Kubernetes built-in load balancing and scale effortlessly. And cloud deployments are no longer a dream when you use Canasta's web app image on ECS, Azure Container Instances, EKS, AKS, etc. Okay, so I want to go through a quick rundown of how you can use Canasta. Unfortunately, since I was only given 10 minutes, I can't just demonstrate spinning up Canasta live because that would take too long, but you can visit the demo by visiting that link. Let me type it in the chat to make it easier for everybody to use. 3.209.11.136. Please don't DDoS this. That'd be really mean. Thank you. So yeah, overall, it's pretty easy to follow these steps. Just have Docker Engine running. So you can install it easily. That takes like 5 minutes if you have a fresh instance of EC2 or something like that. You just need to git clone the Canasta stack repo, set up your .env, run docker compose upd, and then, if you don't have a local settings.php, you can follow the MediaWiki setup using the following local, database settings. And if you do have an existing local settings, then you just need to import your database into the folder where the database is stored, and you're done. And then, after that, if you didn't have a local settings before, just place it in our config folder, and you're done. You can visit it, and you'll see it working. And so this demo, that's exactly what I did. The only caveat was there's a small bug with skins, so I fixed it with that. But I'm not exaggerating. This is literally all I did. And within, this is less than 30 minutes. And I had a MediaWiki instance up and running with Elasticsearch, with Visual Editor, all working. So what's next? Well, Canasta's source code is currently available on GitHub with a release to the general public to come soon. We aim for the project to be run independently from any company or an individual in the future. A preliminary version of Canasta is working today. So in the future, we're aiming to finalize the specifications and improve the image to better support performance for more high traffic websites and wikis that need to be beefier, I guess. So some of the features that we've thought of are included here: automatic HTTPS, having that manager image separate. That allows the job queue runner and all that stuff to be on a different image. Creating sorter pages in the page exchange format, as I mentioned, in the beginning, which is one of like the few key goals that Yaron picked when starting Project Canasta. And we'll try to add in memcached, Redis, Varnish, etc. All right, so if you like more information, I'll stick around to answer questions, and feel free to send me emails to my email address. So I'm also available on MediaWiki Stakeholders Matrix. Okay, thank you for your time, guys.
Awesome. Thanks so much, Jeffrey. That's awesome. We are ready for Greg.
There we are.
It
took a little bit longer than I thought. So let me share my screen. Thank you, everybody, for being patient. Excellent. There we go. All right. So welcome, everybody, and thank you for your attention. I'm gonna dial it back a little bit. I know we've listened to some awesome presentations about Docker and Kubernetes and automation and everything, and I'm gonna dial it back a little bit and talk about my journey over the past year, bringing MediaWiki development into a Docker setup, and a couple of things I've learned along the way, and so. And also a little bit touch on hosting and Amazon Web Services, because that's where we host. Let's see, how do I do this? There we go. So first, a little bit about me. I'm a full stack MediaWiki developer. I'm with Pegasystems. Previously, I was the founder and consultant at Equality Technology, so you might know me from there. I've been a MediaWiki developer and wiki enthusiast since really before MediaWiki, just starting out with the original Ward Cunningham C2 wiki and Perl wikis. When I was a consultant, I developed a professionally supported fork of the NASA project, the MESA project that Rich mentioned. And, that project is Ansible driven. It teaches you system administration if you don't already know it. It requires system administration knowledge since you really kind of get into the guts a little bit of the systems. and obviously requires Ansible knowledge if you're gonna modify and customize it. It does support multiple nodes in a cluster, and but those install on VMs, kind of like traditional, virtual machines, rather than Docker containers. QualityBox itself is defunct, so I want to mention that because there's a big slide called QualityBox, but there's no more QualityBox. There is a Mesa. So with that background, I came to Pega, and I'm working in a IT environment for a software company. Pega is a major software vendor in low-code business process automation, but working in IT with a new group and a new project, all the MediaWiki development is outsourced. And so we don't have, just a little caveat, we don't have the same engineering and tooling and process as our product teams. Actually, I'm the single developer on the team. And so the challenge was that we already had, when I joined the company, already had a production and hosting environment at AWS. We already had a vendor for Amazon Web Services, and we're using Elastic Container Services called ECS instead of the more traditional Amazon EC2 environment that you might have heard of if you're also familiar with Amazon. And specifically, we use the Fargate launch type, which is great for easy scaling, but also brings some challenges. So here are some of the challenges that I encountered along the way. We use multiple private code repositories. The whole process of our build is composer driven. And some of the we have a bunch of secrets, and how do we manage those? The environments that we have hosted in AWS are limited because they cost money, and setup time, and there's a lot to it. So basically, we only have the traditional 3-tier environments, right, where you have dev, QA, and production. So the way that I've solved those is using Composer local JSON to install all of the code repositories that we pull from, including private code repositories with environment variables for secrets and login. Since it's composer driven, we use a multi-stage build so that we can pull from Composer, get Composer into the environment, into the image, and then run Composer, and then then pull MediaWiki, and then using the Composer aspect, run the Composer install on all the repository definitions that we have. The secrets we can put into environment variables, so that after the different stages are built, we can dispose of those. And we actually have to do better secret management in the future. But the sandbox is what I created using Docker. It runs on Docker desktop, so that means you can have unlimited environments. Every developer can have their own sandbox. And every developer can actually have multiple sandboxes because they just have to check out the code into a different directory and run that on Docker desktop. So the limit is really just whatever hardware you have on your laptop, your workstation. There is no cost. You're not hosting in Amazon. It's right there on your local machine. There is no vendor involved. There's no ops involvement to set up, a special environment for Greg. And, in the future, maybe we could, host all this in a data center and have environments spin up automatically, which is, I'm sure, what happens in the Kubernetes style development if you're not using Minikube. But anyway, those are some of the challenges and the solutions that I was able to apply with Docker. Playing in the sandbox, what does it look like? This isn't proprietary in any way, so I think I can just give you a glimpse without revealing. Let's see. Yeah, so here on the right is the production environment, and then you almost an exact mirror image on the left is running off my local host port 8082, exact same system, database service, Elasticsearch service, MediaWiki web Apache service, all running together. And the whole secret to that is really the Docker Compose file. So this whole system that I built, the sandbox that I built, is really based off the Docker Compose that comes with MediaWiki. So if you're looking to get started with Docker, that's where I started, is looking at MediaWiki's own distributed Docker Compose file and what's called MediaWiki Docker, which is listed on MediaWiki.org. So you can find more information there. Some of the other challenges that we still are struggling with, and I call it dirt in the sandbox. The volumes for data persistence, anonymous volumes work great for the database and for Elasticsearch, but somehow, I don't know why, but it wouldn't work when I tried to volume in the container onto my local machine. I wanted to have, everything that was in var www or var www/html. I wanted to have all of that on my local machine so I could easily develop it with my local IDE, but it wasn't working until I used the name volume with a local driver. And if it works, great, but I still don't understand what the difference is and why that wouldn't work with just an anonymous volume. And so maybe someone can help me on that. And also file permissions between host and container. I know the MediaWiki Docker project uses a quick shell script or shell substitution to get the current user and group ID and then map that to the container. We kind of brute force it with just choning everything with the www -data user, but that doesn't map to a local user on the host. So essentially we end up doing a chmod 777, which is not great. So I really have to figure out the file permission issue between host and container. And the last thing I want to mention is one of the tools that I discovered along the way trying to manage Docker was this tool called Dive. And as you've seen in other presentations, everything in a Docker image is like a layer cake. And over time, the bigger and bigger your image gets, the more you're wondering what the heck is in there in that big haystack. Dive is a cool CLI tool that lets you inspect your image and gives you the ability to really, just dive into. Well, yeah, I guess that's why they called it that. Dive into the layers of the cake and see for each step, like what does it add? What files changed? What files got updated? What files got added? And so you can really figure out if your image is now 2 gigabytes in size and it started out at 200 megs, where did all the stuffing come from? So check that out. I'll leave a link in the Etherpad later. And so that's all I have. And I look forward to any conversations and chats later. Thanks.
Awesome. Thank you so much, Greg. Ariel, and provide the slides, but I need Ariel to join. There we go. Awesome.
Are we good?
I am working on it.
Okay. And thank you very much for being willing to be my slide person yet again.
I'm always happy to be your slide person. Okay, so let me share window. That window.
No one has to read any code on these slides, so not to worry.
Does that look like your presentation?
Yes, it does.
Awesome. I'm going to see if I can turn my video off.
Whoa. Well done.
Yeah, unfortunately, it didn't completely go away, but at least it's less distracting. So the floor is yours.
All right, let's get started. Wow, this is going to be a very fast 10 minutes because, as usual, this talk would really take 17, and I don't have it. I have 10. So this is about testing SQL XML dumps from MediaWiki via Docker, or at least working on it. Next slide, please. So you're going to wonder where the questions for this presentation came from, and this is what I'm going to tell you. Next slide, please. Right, who am I? Next slide, please. My name's Ariel. I don't care about titles. I don't have a lot of content. What is important is that I've been managing the production of these dumps of content from the wiki projects and various other public datasets for over 10 years. And I've been the sole person on that for pretty much all those 10 years. Next slide, please. Right, so maybe a lot of you, or maybe none of you know what the dumps are. Well, maybe one person does. So let's talk about that for a second. Next slide, please. Okay, so what we do is we produce content of all of the wiki projects. So that means English language Wikipedia, but also your favorite small language Wiktionary or anything else that's public. We produce it twice a month. One version of it has all the revisions. It's there for you to download and use it how you want to. That means you can stand up your mirror or whatever you want. And there's a bunch of other data sets, but this is the one that I'm most interested in for this talk. Next slide, please. So yeah, I hope you think they're important. We do. So then it's nice if they actually do run twice a month and they don't break. So CI, right? Next slide, please. Okay, well, not CI, because it turns out, so first off, changes right now to MediaWiki core, they take, a half hour on a good day, and we cannot add time to that. We should be taking time away. But also there's tests we want to do that involve running parts of these dump scripts across multiple servers, seeing if, locking is happening in the right way, taking the output and combining it, and then looking to see if that output compares with. Anyways, it's stuff our CI environment is not set up to handle. And there's no reason it should be. It's set up for things like a web request, because that is our primary work. Next slide, please. Okay, well, local install, that does sound good. Next slide, please. And in fact, I do test with a local install. I have a full wiki farm that has enough data in it that one of the tests takes, probably 2 hours to run if I go that route. But nobody else has a copy of that. And telling them how to set it up would be slow and complicated. And pretty soon, like actually right now, this minute, another person has been hired and will begin to work with me on these dumps, which is awesome, and these other data sets. But they're going to need to be able to test things too. They're not even going to be on my OS, which is a Linux distro. They'll be on Mac. So how's that going to work? Next slide, please. Yeah, so if we can't do a local install, we can't do CI, what can we do? Next slide, please. I'm sure I'm not giving anything away in that image next to the little blurb that says mounted volumes and containers in it, right? Nobody would have any idea what the possible solution could be given the title of this talk. Next slide, please. And yes, of course, Docker is the way to go. But how hard is that going to be to install compared to the mess that we have now? Next slide, please. Okay, so for what I've written so far, at any rate, the code that I have available, I wanted networking to be easy. So I wanted somebody to be able to sit on their command line and just SSH in or NSLOOKUP or whatever to any container with a human readable name. I wanted the same thing from within all the containers. I wanted it to be easy to get over to any of the DB server instances. And this turns out it's not. There's not a nice solution. I mean, I chose one that I thought was less icky, but it's still icky. I don't love how we set up our database files. The intent is that they would be unmounted in volume, but this, the way I have it right now, requires certain binaries that are used in the install of the package, frankly, when it's installed on any distribution, to be available on your local host. That's not nice. Next slide, please. So, well, it's true. That's gross. So why wouldn't I just use Docker Compose? That's a thing that several other approaches here today do use, and they might rely on the official MariaDB images and such like that. Why can't we go that route? Next slide, please. Well, I want it to look like as much as like production as possible. So that's one thing, and that means that there's and those databases in production are not containerized, and there's not plans for that. But it means that there's certain things in those configuration settings that I want to have locally. For example, max packet length. We need to have that because the dumps are actually broken on that. So, but we also want to be able to run on specific branches of MediaWiki and multiple at a time, and have all the vendor libraries that are already checked out and committed instead of whatever Compose might see. This is just, it's very important to me. So next slide, please. Okay, so that is complicated. What can we do to make it better? That's a great question. Next slide, please. I actually have not figured out what we'll do for networking. We'll be looking at that. But right now, I mean, an easy win is run all the MariaDB install stuff from binaries that are in a container, and then we don't care, about your local install. We don't touch anything there, or your local host. Having a reasonable default config, that the only thing you do is give us a directory where we can scribble things, and then we go check things out, and we even have some default content to load in that would work, and a default config for your wiki farm, and all these things, and presumably predefined test suite, tiny, that would just work, so that if you just click out of the box, it would do something reasonable. Next slide, please. So then after all this, what does it take to run it? Yeah, good question. Next slide, please. It turns out that running it is pretty easy. Actually, building any of these is pretty easy. Once you do the initial, get the binaries here and get your repos there, like it's one Python script, and you can say base or build or create or start, stop, whatever. So that's pretty easy. So you would just start the whole test cluster, whichever one you've defined, and then you can SSH into any of the containers. You can run any run any tests from within the containers. You have access to the DB servers via MySQL right on the command line in those containers. And then, however, because your repos all live outside of these containers and mounted volumes, of course, you have your favorite IDE or editor to use to make changes. Next slide, please. Yes, so how does it all work really, really fast? Because we're probably nearly over time. Next slide, please. It's one Python script, but there's a lot of helpers. So there's, of course, separate Docker files and little scripts that run inside the containers. But basically, there's a base image that has, it's based on Buster right now, and of course, it could be based on something else later, that does the apt setup so that everything pulls from our apt repos, getting our versions of PHP or anything else. Then for each container type, so PHP FPM or HTTPD, yes, those are all separate containers, or MariaDB, primary, and so forth, there is a separate base image. Then there's and that just has all the packages and directories that we need. And then there's a final image, which will have names of other containers that are needed baked in. So for example, your MediaWiki installation needs to know where to find that database primary server. And so that will be baked in at that point for that cluster. Your DB credentials are defined in the configuration file. This is YAML right now. Yeah, every configuration file format sucks, except the one that you're not using. But anyways, the numbers of instances you want to spin up for a cluster, all that stuff is there. And you can right now import an SQL file that you have put together, presumably from sweat and blood over time. Next slide, please. I didn't actually say the words external store and DB replicas. Oh, maybe I didn't talk about replicas. Okay, well, so here's the truth about those. Next slide, please. Those are not there yet. Okay, but they will be. The hard work actually is already, I think, in getting the DB primary stood up correctly and getting PHP FPM in a separate little container, getting everything to talk to each other. These will take work, but it's not as bad as one might think. But these are things that I want to add, and there are plenty of them. Next slide, please. It's not really all that bad. Next slide, please. There is actually a real repo. There is code in it. Until yesterday, it did work. Today, it does not because I broke everything. Check back in a day or two. I promise it will be better. And it will have that basic functionality. I mean, it did, and it will have it again. There is just a really long to-do list. Next slide, please. So future developments, indeed. Let's see. Next slide, please. That's all my contact info. I'll make these slides available somewhere or other, and I'll put a link somewhere or other to be coordinated with Cindy, I suppose. And that repo, it's temporary. Eventually, it'll get moved to Garrett or GitLab, whichever is appropriate at that time. One of the Wikimedia repos. Next slide, please. And yes, we are done. Next slide, please. Everything that was in this talk, that was an image that's not from here, was a screenshot that I took. The rest of these were images uploaded by volunteers who make the content that are the reason we're here at all. So thanks to all of them for that. And by the way, if you did not get my Mark Zuckerberg joke, I'm not going to explain it because explaining a joke is absolutely the worst thing ever. Next slide, please. Thanks a lot. That's all I got.
Awesome.
Should I be leaving at this point, or does somebody else just get it?
Yeah, you will leave. Mark is coming now.
Okay.
Thanks, Ariel. Hopefully Mark is coming now. Mark, you are next. Did anybody see Mark? There's Mark. Awesome. Hello.
How do I share the screen?
On the bottom, there's a little picture of a monitor with a red line through it. Click on that.
Oh yeah, okay. I didn't. Let's see. I'm sorry. You're covering my screen here. Let's see. Oh, that was the wrong thing. Is it sharing? There it is. Okay. So in this presentation, I'm going to show you how to take, or how I took, the Meg file from Professional Wiki, their external content repository, and show you how with few updates, We can just copy it into place and use it to reliably run tests locally via GitHub Actions to help with continuous integration or even GitLab jobs. First of all, I have to say, makefiles have a bad rap. I suspect this is because there's a lot of dynamic language programmers out there who think of makefiles as being concerned with compiled code. I imagine that the mere mention of a makefile evokes floppy disks for these people.
Hey, Mark, we can't see anything above your beard. Just FYI, if you want us to see the rest of your face.
Well, the beard is the beautiful part.
Thank you.
Makefiles can be a very good way, though, to organize a set of shell commands so that they can be executed reliably. So, for this example, I've taken I forked the Semantic organization extension. I use this extension because I was curious about it. It is relatively active. It has some recent commits, and it does not have any GitHub action integration. I didn't start from nothing, though. As I said, I'm using the makefile from Professional Wiki. That's pretty simple. It has one target, the CI target, and it's invoked with make CI. And that allows you to test and analyze the code. The CI target invokes test and CS targets, which then invoke tests with PHP unit, MediaWiki parser test framework, and then the code analysis tool of PHP code sniffer, PHP stan, and Psalm, respectively. So here's an example of what the simplicity of this makefile, what it looks like. So just type make and away you go. For any extension that has unit tests and parser tests, the makefile will take care of running them if you run it in your existing MediaWiki setup. So when I first copied this in and ran it, it was unsatisfactory because there was no PHP unit XML dist. As I said, I'm using the Semantic organization extension, which is kind of bare bones when it comes to anything like tests or continuous integration. So it works, but it's a good example for adding these things. So makefiles, they're made for creating files out of dependencies. So we can add, here you can see on the screen, we can add a dependent target to create the PHP unit XML dist file. That's pretty easily. That's a generic file. It'll run all the tests in the test subdirectory, but there are no tests there, so none are done now. I should point out, I'm only showing how to use makefiles to do all this, not how to write tests. So the writing tests is something that's left as an exercise for a developer. So even though we have this makefile, makes it a little bit farther now. It runs the test, except no tests are executed because there are no tests there. And then it gets to the parser tests. The parser tests don't run because there's no parser test. And again, we're missing a file, but we're going to go through this a few times. So instead of doing that, let's just test for the existence of the parser tests file and then only run it if we see it. So since the makefile will stop executing, it'll fail if shell command returns a false value. We want to look for what's going to give us the false value and then skip the test if it would give us a false value. So we do that here with the test. We check for the parser test text file. If it does not exist, we don't run the test. If it does exist, then the test for the non-existence of the file fails, and we run the test. So we go through that a few times, And then you can see we have a simple make file here. I believe example. So yeah, you can see there, it's running. It runs pretty quick, and let's see, it runs pretty quick. I said it takes less than 2 seconds to run all that. But you can see here also that I've in the document I've substituted MW install path for the relative directory so that we can move the extension around and whatnot. I prefer to do that anyway. So that's great. What about running on GitHub? GitHub uses actions. You can set up actions, but you don't want to go through the whole MediaWiki setup and all that. So you can see how this works on I have basically this set up so that, let's see if it, yeah, there we go. I have a make file that I copied from Semantic MediaWiki, or a main.yaml file that I copied from Semantic MediaWiki, and you can see it runs these different things. If you want to get Composer, you download it, and then you create it. Anyway, it does all that in the action file, the main.yaml. But I'm talking about make files. So let's change this so that the main.yaml calls the make file. So we do that. Let's see. And you can see that it calls the make file. And you'll be able to click on this later. Maybe I can click on it now. Bring this down. Oh, y'all can't see that because I'm sharing my only the Emacs screen. Never mind. It works like a dream, though. You'll have to trust me. I can show you the link later. What about using a container on the local system? Well, that's a good point. We want to be able to test in our make file for whenever it's running in the make file in a container already. And if it's running in a container, you can see here I do these tests for if it's running GitLab or GitHub. And then I say if it's running in a container, run the make file in container. If it's not, then it sets up a Docker instance. It shares, copies in environment variables, it mounts things, and then it runs Docker. Actually, I don't use Docker. I use Podman, but that's another story. So I can do that. Let me demonstrate here. Git checkout. So I have two different, it defaults to 135. There's a problem with running the parser tests on 135, so this should fail here. Yes, it fails after the test run. The test runs successfully, but there's some other problem here that I have not been able to figure out. But to show you that it works, I go over here to, I just type change to 136, and it works. It runs it takes a while to run the parser test. It takes like 15 seconds. So actually, let's remove the tests so it doesn't run parser tests anymore. And then let's run again. And you can see that it runs much faster this time. It runs about 4 seconds, under 5 seconds. Right now, you'll see that I only have environment set up for 135 and 136. If I wanted to set up 137, it would build all that. We're not going to wait for that right now. That's another 5 minutes it would take. I don't have time to do that right now. So there we go. Thank you very much. That's my time. It's checking out things right now. You can see that it's doing that. So anyway, that's my presentation, and show you how I can run tests on using the same files on GitHub or locally. And if I make change to the test, it's automatically invoked on or on the way the test is run. It's automatically invoked on both GitHub and local development. So that's it. Are you there, Cindy?
I am there. I was just waiting for you to stop talking, and then you stopped talking. Thank you, Mark. That was great. And we are now, last but not least, at our very last talk. So Lex, I see Lex is waiting. So I will add him. And Mark, if you click the leave at the top right, that'll.
Okay, thank you, Cindy. I guess you can see my mind map and you can hear me well. I guess so. Right. Okay. Thank you. I'd quickly like to share my current version of the dishwasher in a kitchen approach. The idea was to have a single MediaWiki on a single system with the utmost simplicity of running it, comparable to a dishwasher where you actually just have to slide it in, connect fresh water, wastewater, and electricity, and it runs. So in my case, this would be fill in a Docker Compose, run it, and then initialize the database and the snapshots. And to operate it, much like a dishwasher, you would have some knobs for snapshots, for extensions, for content exchange, and for upgrades. Now, let's see how that's done. Most of these concepts, of course, were mentioned in many talks, so I'm going to be quick on some aspects. I'm using one container image PHP from scratch, from PHP. Once that's done, I'm adding MediaWiki core and selected extensions which are molded into the container. So the W file that was created by Ansible is going to be molded into this MediaWiki container, as you can see down on the left. And on the right, you can see the customizations I'm running. So I'm including two files. One is an MWM local settings PHP, which is actually populated and managed by an SQLite database in order to automate or automagically add and remove extensions, skins, and upgrades and everything. Also to enable reverting snapshots. And then since not everything can be automated, we want to be able to add manual settings. So I'm including an MWM local settings manual PHP. Now, when we run it, so this would be the unboxing. So here, this would be the Docker Compose. that we run. You can see classic MariaDB My MediaWiki. This is my container here, a couple of volumes, and everything is actually configured with environment variables, including the S3 snapshot destinations. You can also use S3 compatible local services, like, for example, Minio. And everything is, except for the two Composer local JSON and Composer lock files, everything is managed in, or is used with Docker managed volumes. So there's no local volumes that are mounted, except for the two files. Now let's see, and then of course the only thing you have to do is to run two scripts to initialize the database and initialize the repository on the S3 compatible service. Now interestingly, how does it look like in the container? So in the container, you've got the HTML directory, of course. Everything in there is actually immutable or ephemeral, except, of course, the extensions, images, skins, the two Composer local aspects, and the vendor files. And in the config directory, I am having the two customization files and the SQLite database. And the manage folder down here would contain the bash scripts to actually operate the wiki based on this setup. So let's have a look at how that works. Snapshots. I'm using Restic for this. I'm not sure whether you know that. It's fantastically simple and reliable. So I can take, view, restore, compare, and forget snapshots. This is a screenshot as it looks like right now. So I'm including the instructions down here. It's essentially just running bash scripts at the command line prompt. In terms of extensions, that's now hinting another idea we are following now for more than 5 years, to have a certified extensions catalog run or sort of curated by MWStake. So imagine we have some site, some GitHub site or wherever, where we store an extension JSON, which would feature the curated extensions approved by or managed by MWStake, and then you can just enable an extension or disable an extension. On top of that, I'm including a couple of functionalities to inject or import and export content, both from local Wikitext files, GitHub hosted repositories, or actually directly from any other MediaWiki API. And in terms of upgrades, the idea is that you only have to replace the container with the mold-in MediaWiki version, and then repopulate the vendor directory, and it should then run out of the box. Yep, that was it. Thank you.
That was sudden. Awesome. Thank you so much, Lex. That was great.
You're welcome.
So that was the last of our presentations. And as I promised at the beginning, so what we're going to do now is do one more loop through the speakers, giving them a chance to react to what they've heard the other folks say, you know, indicate, you know, any questions, any further things they'd like to collaborate on. So once we go through the loop of the 12 speakers, we'll then take another final short break, and then we'll come back and go through the questions. There are some questions already on the Etherpad. If you have other questions, you can go ahead and ask them there, or if you want to have the stage, you can also click the blue button up in the corner and join us. So with that being said, I will invite Máté back for any thoughts. You can rejoin the call. Yeah. I'll let you in here.
Nice. Thank you for that.
Awesome. So you can go ahead if you have any additional thoughts, anything else you want to share.
Well, if anybody has any questions, feel free to ask them. I'm looking at the Etherpad. It seems the only question was about horizontal code auto-scaling, which apparently was answered.
Awesome. Okay. Yeah, if you have nothing, that's fine too.
Sorry, I just had to rejoin because apparently the camera didn't work correctly after I reactivated my laptop screen. So
cool. Okay. Yeah. So the idea is if you have any additional thoughts, anything from having seen the other presentations, and you know, if there's nothing else that you want to add at this point, that's fine, and we'll come back later if anybody has any questions for you. And that goes to all the speakers.
Hey, Cindy, I think Richard has a question.
Richard, is there a page on MediaWiki.org that provides a listing of the emerging options and comparison of the various defining features? We'll come back to that when we do the full Q&A section in a minute. Right now, and Jeffrey, I don't know, did I let you in? Not that you're not welcome here. All the speakers can come back on now. I'm just going to go in order of the speakers. So, awesome. So Giuseppe, do you want to join? Yes.
Hello. Okay, I'm here. So I actually have a comment from all the presentations that came after mine. I mean, I'm aware of the work that Adam is doing and the other people around the Wikimedia movement are doing regarding dev environments, but I've noticed in general that there's a huge preference for using Docker Composer. Now, I kind of feel like that's because of the less steep learning curve. It's much easier, right, to use Docker Compose. Like using properly Kubernetes is complex. And I think that it only has value as a dev environment if you're also running Kubernetes in production. So to keep using basically the same structure, both in development and in production. My dream is that one day our charts will be complete enough to allow anybody to just spin up a cluster on GKE or another EKS or one of these managed Kubernetes clusters and just get up a MediaWiki instance running with possibly more stuff that they're used to when they're using like things like simple PHP hosting. But right now we've seen a lot of dev environments are actually going in another direction with Docker Compose, and I was wondering what's the reason for everybody, if it's just the learning curve at the start or it's something else more deep that I don't see.
So the other speakers can address that when they come up. I'll turn it over to Adam.
Yeah, I can definitely say one thing about that as well, Giuseppe, because for me, definitely I never intended on creating a development environment in the first place. I was just playing around with Docker Compose, and then it turned into a development environment. And definitely part of it was a learning curve thing as well. But having talked to lots of people that do things with MediaWiki and have development environments, simplicity is definitely something people want. As Jeroen just said in the chat. And then on the whole, I think this is the first time ever, I think, I've heard so many people come together and say so many things about containers and MediaWiki before. So this was really nice. I think we've had like little tracks at hackathons before, but this was, yeah, there's a lot more going on than there was a couple of years ago, that's for sure. And it's going to be interesting to see how, what we can continue to do here. I'm definitely looking forward to a nice, shiny future where there's a nice, simple development environment maybe, but also a fully fledged, all of the bells and whistles development environment, which, that sounds super nice to me, but we're definitely a little way away from that, at least.
Yeah, we also only utilize Docker Compose for individual development environments, and even those Docker Compose configurations only orchestrate essentially Nginx and PHP, FPM, and whatever is required to start those up. But the database and the microservices that our application might call are all provided in a shared dev environment and the development Kubernetes cluster, because there would be no way to spin up that amount of dependencies on a single machine. As somebody wiser than me once put it, trying to do that is equivalent to becoming multi-substrate and supporting multiple cloud providers, but one of them is the worst you have ever seen in a single laptop.
Yeah, for us, we would like to get to a Kubernetes environment in production, but since we don't use that now in production, we're working with containers, keep everything consistent, and it is simpler.
Yeah, and I'll say one more thing quickly about what was towards the end of my last slide. So we have this Scaffold-based, Helm file-based, Minikube-based development environment that's super nice. But we also still have individual development environments for all of the individual components that are part of that as well. So we only really use the big development environment for, essentially when we're making changes to actual production versus individual services. So I definitely think there's probably always a space for both ends of this spectrum to exist as well. I don't think there is a silver bullet, unfortunately. That'd be nice.
Absolutely. Okay. Let's see if Gökhan or Jesse are here. If they have anything to say, or actually, if any of these speakers wanted just to request to share, and I'll add you. I think I can add up to 9 at a time. Okay, Lex, Alexander, either of you.
Yeah, maybe I have one question that I already put in the Etherpad. Well, I mean, that's maybe an edge case using these containers where MediaWiki is already installed, and then adding an additional layer like another extension, and then creating an additional layer. But this requires that the database has been set up before, and as Lex pointed out, with SQLite it's easier. But if you want to have, let's say, a matrix testing, let's say for SMW, one time with MySQL, then with Postgres, then with Elasticstore, and so on, is there a way to run just a section that is doing the database setup? Because if you run the install PHP, it requires that local setting is not there, so you have to move it away and then move it back again. So is there a simple way to just say, please just put in the SQL stuff and keep everything else? I'm not aware of this.
I don't think there is a tool. And this is a problem that every development environment that I've ever created that works with multiple sites has always had, because as a developer, you have your local settings there. And if you want to be able to install another site, there's this silly back and forth of moves local settings out of the way so that you can run install.php and then move the settings back and then run update.php. This probably should just be something that we all aim to fix in MediaWiki. I've definitely been working around it for years now, and I don't know why it has to be that way, really.
Yeah, the one thing that we're able to do with a mount in using the MariaDB image that's out of the box is it it automatically will look for a pre-specified SQL file. So we'll take a database dump from production, we'll call it 1.35.SQL, and we'll mount that, and then when the database service initializes, it will actually load all of that into the database. So I don't know if that's your specific question. I know when you're trying to change versions and add extensions and everything, there's all bunches of routines to go through, but at least that's what you can do with Docker to at least initialize the database so that everything runs with production data, and it's got all the different tables that might have been added by all the extensions that are already in your local settings.
Yeah, I wanted to avoid creating those dumps. This was the only solution probably to do this. I thought there might be an easier solution to just having, let's say, an additional maintenance script that is just doing the database part. But I couldn't figure out if this could be easily done. So it's right. And another one, maybe a second question is, it seems to be not that easy to run the JavaScript parts of the test in a headless way. So of course you can set up all the browser stuff and so on, headless browsers, but it seems to not be prepared very well. And I read a great article from the folks of the pop-ups extension. There's a writing about that. This is some way tricky, and you need to tweak a little bit and use NPM. So I'm not sure if something changed here or is on the roadmap.
I can say something there as well, which is that I think there is a drastically large number of different ways that especially JavaScript and browser tests run between extensions, even just within the Wikimedia owned set of extensions, I think, right now. And I can definitely say something about MediaWiki CLI, which is there's also this fresh command and Docker container that you should be able to find on MediaWiki.org. MediaWiki CLI bundles this fresh command up, which provides you a space to run all of these headless browser tests. And Yaron says, is that appropriate for CI on GitHub Actions? I don't see why not. It definitely hasn't been done. But the CLI should totally allow you to do that, yes. But this was actually, coming back to the slides that I did, this was the thing that made us at Wikimedia Germany look at our development environment a bit, is the pain that we were having around browser tests, essentially, and trying to come up with ways to solve that.
All right. Any other last words anybody wants to share before we
I would have a general comment. I feel somehow like we were in the dark ages before there was standardization on electricity systems, and because to 80% we're all pursuing the same goals. So couldn't we just slice the challenges into layers and move the customizations upwards, and so that we don't all have to start from scratch? It's a political issue. It requires willpower. It's not a technical thing, and we don't have to stifle innovation by individuals, of course. But everybody has to configure Apache. There is no competitive advantage if you have a particularly nice SSL certificate. So that is exactly the same. Now, for example, how the interface in terms of a CLI, whatever, looks like, presents itself to the user, that is where the competitive edge comes from. But otherwise, because there's so much stuff, so much intelligence, so many great people, so many great ideas, and 80% is exactly the same.
I totally agree with Lex. That's one of the things that's most frustrating about this is, I have to learn all these other things. I already know a bunch of shell commands, which is why I just use make to organize all my shell commands. But it would be great if there was something that was standard on, like Adam's MWCLI, that could just say, set up a wiki, and away you go. But I guess that's saying. Go ahead.
Yeah, sorry. So I partly agree and partly disagree, Lex, and let me explain why. I think that there are some things that could be used commonly, right? And we could all contribute to, like, I don't know, some basic form of Docker Composer tooling, right? If you want to run a wiki using Docker Compose, or Helm charts from MediaWiki running on Kubernetes, but there are then very different environments in which people want to run stuff, and there's a lot of differentiation there, which I don't think it's, well, maybe it's 20% of the total amount of lines of code, but it's 80% of the work. Anyways,
Sure.
In the end, very clearly, the difference between somebody that wants just to spin up quickly a wiki to see something and what I need to do at Wikimedia we're just in two very different ends of the spectrum, and that's a testament to MediaWiki if you want, but it can serve both ends, right? But I do think that there's too much difference for going much further than some basic work that can be common. But that should be, I totally agree.
Yeah, I think everyone has some really good points here, and I totally agree with Lex's overall sentiment, right? If we all did everything by ourselves and we didn't depend on other people, and we didn't pull in resources, then we would all be growing our own food. We'd be all, just staying at home and taking care of these basic things instead of going to the grocery store, right? So I think there's definitely room to collaborate here, and that's actually one of the reasons why I asked Cindy if she could organize this really helpful workshop, and I think it turned out really well, thanks to everybody, especially Cindy. So I personally am in favor of collaborating. Presenting Canasta, for me, it's not about saying, this is Canasta, we're going to do it our way, and that's it. I think there's much room for collaboration. So for instance, if there's, I think one thing I didn't mention, but it's really important, is Canasta doesn't have a CLI interface right now. And if there is room for synergy to bridge that in with someone else, then that'd be great. And I don't see it as Canasta has to have one CLI. If there's a way to bridge it so that you can have multiple, like a Lego piece, right? Lego pieces don't only connect with one other type of Lego piece; they connect with everything else. So, if there are ways to take advantage of that synergy and to create some sort of interconnection between everyone's ideas, and furthermore, maybe even start sharing even components of other things, right? Little bits of components. I think that's a great idea, and I'm happy to collaborate with as many people who can do this as possible. I understand that not everyone can do that, because people might have their own specific needs for Docker image, and there's just no way to share with like a general image. But I think that's a great conversation to get started. So thanks, Lex, for bringing that up. I love it.
Yeah, so for me, just my sandbox project, it really had a unique, it's not unique to me, but it had the constraint that I had to work backwards. I stepped into an environment where everything was already running in production. It was all these extensions, all this code, private repositories and everything else. And I needed to develop some sort of local dev environment. We had zero local dev environment. So I just did my best to try to figure out, how do I do that? How do I take an existing MediaWiki code base that was like very, kind of spaghetti, not spaghetti, but just like a lot there. And how do I package that up into something that reproduces semi-faithfully all the services and code that were running in production, so that local developers could then make contributions?
Yeah, and I'll say that, one of the reasons, as Jeffrey said, for having this, I heard from so many people, I had so many individual conversations with people about what they were doing. And I was always like, well, you should talk to so-and-so, and you should talk to them. And I wanted to get everybody together into one room so that we could have these conversations and figure out where there were opportunities for folks to build on what other people are doing, to help each other. So yeah, I'm delighted. And what I'm going to do at this point is I'm going to open it up in general to questions. And poor Daniel's been waiting for a while. I'm going to just go ahead and add him right here. And give Daniel the first opportunity to ask a question, but then anybody else who wants to ask, or if Daniel actually wants to make a comment, maybe he's been holding in thoughts through all of the last 3 hours. And I'm going to just skip over the last break because I think we've only got 30 minutes left. So let's just open it up to questions now.
Hey everyone. I hope you can hear me okay. I have not really been holding back anything big. I just, I'm kind of amazed at what you all have been doing. And yeah, hearing that MediaWiki code is a lot to take in and a bit spaghetti is a good plug for my own upcoming talk, which I'm happy to give in a bit. Actually, we're a little bit behind on the schedule, right? I'm not quite sure how things are progressing at this point.
I don't think so. I think we've got another 30 minutes for this. The times on the schedule are in CET. Did you know that? Not UTC? I don't know. That confused me at first.
Okay. No, I'm basically just hanging out and trying to get a good sense of what everyone is doing with MediaWiki and containers.
Awesome. So we had some questions in the Etherpad. I think a lot of them have been answered already in the Etherpad. So let's see. Here's a question for the panel. Did anyone learn anything from or was struck by something from someone else's presentation? In the chat. So I can share.
I learned a ton. I was struck by how much has been going on. It's kind of hard to, like, we're information overload and we're all inundated on a daily basis with everything that's going on in front of our face. But I had no idea that so much work was being done on Canasta. I had no idea that Adam was doing so much work on MediaWiki Docker Dev and the subsequent development of the CLI environment. I had no idea what Blue Spice specific activity was in Docker, in the Docker world, and so on and so on. So and Máté blew me away with everything that they're doing there. So thank you.
I could definitely say one very specific bit of Máté's presentation, which was this bit of Lua code that is running in Nginx to decide which version of MediaWiki to point various websites to, because I found myself at some point in the last year determining that that's probably what we need for one of the things that we're working on, and it's just quite satisfying to come to a presentation where, oh, the code is just there written for me now, and I might just go and write it down from this this presentation slide now.
Yeah, the alternative would be either that or doing it on the PHP level by having some custom entry point that kind of like, I think the Foundation's multi-versus PHP basically does that it consumes some configuration, and then based on that it figures out which slot or which wiki version to load. And probably you could have something similar to that as well, except instead of consulting a static configuration, it could also go to a service. So if you don't want to use Nginx or don't want to use Lua, that is probably an alternative. I think we just went to this because it was ultimately slightly easier to implement than the PHP entry point.
Yeah, I'll add the one interesting thing there is we currently do it the PHP entry point way, but this means that we have to put some sort of shim or alternate entry point in front of a whole bunch of different services. And so doing it at the Nginx level would allow us to disperse this decision across multiple services, all of which need to know which version of MediaWiki essentially is being run.
Yeah, this way it is pretty opaque to all the clients. Nginx layer decides this under the hood, and your client doesn't need to worry at all about what wiki is in what state currently.
Sorry, Justin had a comment in the chat. I think it's a comment, not a question, but if there's a question associated with it. But he says, I'm currently in the process of planning to move our several large wikis from EC2 instances to ECS Fargate via Terraform. It's definitely a challenge, not just architecturally, but in developing and updating the workflow for building and deploying new config from the on-premises GitLab. So that is definitely a challenge. Do we have any?
The one thing there's one thing I forgot to mention about Fargate, which I was supposed to mention, and that is we had this profiling engine, and what the heck's the profiling engine? Anyway, it doesn't matter, but it won't run on Fargate because the way that Fargate is set up right now, you cannot control the system clock, and the system clock that is used in Fargate is very, very sloppy and slow. It actually makes a kernel call. It doesn't operate in user space. So any profiling engine makes so many calls to the clock that if it's not done in user space and interrupts the kernel every time, it's too slow. And so be careful with Fargate if you're going to be trying to run a profiling engine on your services.
So I'm going to go ahead and put Daniel on the spot since he was brave enough to be here. And I know that Daniel's doing some work that's to enable our future MediaWiki and Kubernetes work with config. Anything you want to share about config, or will I steal the thunder from your talk in a few minutes? I think you were not going to cover config in your talk.
I was just thinking about asking a question about this. I'm very curious how people who run MediaWiki in containers or on Kubernetes go about deploying configuration changes. Because of course it's kind of inconvenient having to rebuild an image and deploy an image just to change configuration. So I would love to hear if you have come up with any solutions to that issue and what they look like. I already know that Phantom has been doing a lot of work around configuration, and they manage a lot of their configuration in a database. But I'm curious to hear what others have been working on.
Can I quickly comment on this? I'm using environment variables controlled uniquely in Docker Compose plus an SQLite database, which is compiled into a PHP that is required by the ephemeral container internal local settings PHP, which also means if that compiled PHP is missing, it will just run in a standard mode, so all the configurations will be lost. But so I'm having the configuration in environment variables in Docker Compose and in an SQLite database.
And if the contents of the database change, how will that propagate? Will you have to restart the container, or can you somehow?
No. There is, so we have to set, I'm not sure where Alexander Gesinn, I think he thought I'm having the content in the SQLite database. That's not true. Content is in MySQL. SQLite is just the configuration. And whenever I can manually recompile it, and it's, I can even manually add, so I mean, through scripts, I can add statements to it. But most importantly, whenever I run a RESTIC operation, so I take a snapshot, restore a snapshot or so, this database is dropped, or the file is deleted and recompiled.
Yeah, we are currently looking into two different things, or well, we're actually looking into a number of things. So one thing that we are planning to do is we want to allow MediaWiki to load configuration from files that are not PHP, right? Not code, but actual configuration files. We will definitely support JSON. We will very, very likely support YAML, though YAML is a little bit scary in terms of performance and also in terms of funny edge cases in in the format itself. Be careful when you set your content language to Norwegian. It may end up being false because NO, of course, is a Boolean. Yeah, fun stuff like that. Anyway, the other thing, of course, is generating PHP. So, which is, why would you do that? For performance reasons. The fastest thing you can do in PHP is read a PHP file. It's faster than any cache you can come up with. Invalidating can be a little bit tricky depending on your setup, but it's definitely fast. So pre-generating configuration as, let's say, dump PHP, not a lot of logic in there, it can be pretty nice. So it is interesting to hear that this is also what others have been doing, right? Compiling. When you say compiling a PHP from a database, I assume that is what is happening there. Did I get that right?
Yes, I just posted the. I mean, sorry. Are you talking to me?
Yes, Lex, please.
Okay, sorry. I just posted the link where you have the collection of files that manages SQLite in all aspects.
And have any of you experimented with having configuration in JSON or YAML files, using Kubernetes config maps or anything like that? I guess in some respects it's pretty specific to Wikimedia, because if you serve enough requests, the speed at which you read a config file really starts to matter. And also the speed at which you can deploy configuration changes across 100 application servers starts to matter. But I'm just curious what others have been coming up with.
Mark said JSON in the chat.
Yeah, JSON is great if you don't have to edit or read it by hand. Especially if you have long strings, right, that you can't wrap, and everything is on one line, then JSON becomes a real drag to deal with. But yes, I'm not a great fan of YAML, but we'll end up with some mix and we'll end up supporting both, probably.
But yeah, Daniel, to comment a bit, I don't think that many others have a problem of shutting off a few milliseconds from every request by not loading the configuration from an uncached source, right, like we have. I think maybe Fandom has the same kind of problem with, I know they cache their configuration when they fetch it from the databases. But I think in general, I was taking a look at what Lex has done. I think that's a generally good solution for somebody that doesn't need that kind of coordination across multiple servers, right? That's why I don't think that there's a lot of solutions for our problems unless you go to very large Wiki farms, basically.
For us, the cost of fetching the configuration from Memcache or the database is an acceptable cost because it is actually lower than the cost of fetching extension registration configuration from APCU.
Right, yes, which I suspect it's true for us as well at this point, given cost of APCU. Sorry, Justin, I saw you finally solved your video issues.
Yeah, I was sharing with an application issue on Windows. Because I'm streaming through a work computer, so it's all quirky. Yeah, so no, I just wanted to, well, first of all, thank you for having this. And I just wanted to kind of respond to about my points about what we're doing or what I'm doing with our wikis. Yeah, and like I said, moving to ECS and Fargate from running natively on EC2 instances, is a big change. And I'm not currently even using Docker for all of that, and so I'm kind of going kind of whole hog. Not only moving from containers to, from bare metal to containers, but then also so having to figure out how to containerize all of MediaWiki and all of that, but then also how to automate that with Terraform and all that, because I'm kind of new to that stuff as well. But then there's also that workflow, as I had mentioned, about managing how do you get the MediaWiki config, the MediaWiki code and the config, and then architect that, in terms of do you have, and it very much depends obviously on your system architecture. If you're just containers, do you put your code and your config in your containers? Do you put them on a shared file or on some file system that they can all access? For instance, we keep our images on an NFS file system, Amazon EFS. So would I do the same thing with that, or would I put the code and the configs in the containers? The code is the config is currently managed on the bare metal in a couple of different ways. There's like Nginx and PHP and Varnish and all that, which is managed with Salt to do the configuration management on the system, similar to Puppet or Chef. But then there's also the code or the configuration files themselves, the local settings and such, that are actually created on a deployment server and then pushed down to the MediaWiki directory on the various EC2 servers. So it's kind of messy how that's done, because like all the configuration parameters, the variables and all that's all kept in in some kind of repository like Salt Pillars or Vault or whatever it might be. So kind of pulling all that together into the config and then getting that together with the code, and then figuring out what's the right way to do that when you have all these containers. And someone brought up the point of, you don't want to necessarily have to, if I make a small tiny change to a local settings.php, and if that's embedded in the containers like the PHP FPM containers, or whichever containers need to load the MediaWiki code, then do I have to rebuild all that, these 400 meg image containers? Obviously, if your config is just a single layer of that, that can speed the process up. But again, it requires restarting everything. Whereas if you have it on a shared file system, the code can just pick up that change automatically. So it's just a lot of trade-offs, obviously, especially relating to performance and this and that. And everyone has different systems. There's been a lot of interesting conversations and presentations here about very small systems. I want to build this single dev-off, or this single one-off dev server versus, you have Wikipedia and then kind of everyone in between. And that's kind of where we are, big enough to be load balanced, heavy traffic, multiple wikis, but, only a handful. It's not like the people who host and do hundreds or thousands of wikis. So there's just so many variations in architectural requirements and configuration management requirements and so forth that, that's why I think people are seeing why it's difficult to have any kind of a one-size-fits-all solution or one-size-fits-a-few, because there is just so much variety.
So I can give some comments personally, because I've gone through some of your dilemmas when we started working towards MediaWiki and Kubernetes. Of course, that's a different dimension, but I think that in general, whether you use a shared volume for a shared read-only volume to share your code with your containers, or you ship your code to a volume on the actual file system and you share it between the containers, so it's a local share. That simplifies a lot of your work, because it means basically that you lose the whole need for a very up-to-date pipeline for every commit you do, right? Your pipeline just needs to deploy to these local or shared volumes, and you don't need to rebuild images for every layer, and your images you can probably depend on stock images like, I don't know, the PHP FPM image from Docker Hub, the official one, which is currently pretty well updated. I do think that it comes with some costs, some trade-offs. The trade-offs are basically, well, one, you're again introducing a shared file system, which is a problem in production. NFS is not by chance nicknamed the nightmare file system by anybody who's run a website that uses NFS in any way. And under the hood, a lot of what AWS does is some form of glorified or under-glorified NFS. But the other thing is probably security a bit, like unless you have high guarantees that your volume will be read-only on the guest machine, that's a huge way, like in general, right, sharing code between multiple machines is a huge way of allowing a single attack to basically own the whole farm.
Sure, that's a really good point, especially because if you're doing, like for instance, I currently am being on EC2, you simply mount up the file system and then access it by your code, whether it's in containers or not, you can just map it in. But then if you move to say ECS, okay, now you're still running on EC2 instances, which you have some degree of control over. But Fargate detaches it even from that, where you're still running technically on ECS, but you have no visibility into it or no control over it or anything. So you don't know what else is running on that. But you can map your, you can access that EFS volume from your container, but it's doing a lot of, magic under the hood to get that mounted up to the specific EC2 instances that you don't see. So, are there any risks there to that getting your images up to your Fargate tasks in a way that prevents access by any kind of malicious actors that may be using the same EC2 instances, transparently? So it's certainly a concern. And again, it's always about trade-offs, right? Because the other problem with NFS can be performance, right? Because initially when they launched DFS, you didn't have the ability to provision any kind of performance and your IOPS, which they did eventually add that. But MediaWiki is not that big. I think our deployment of it is around 500 megabytes or something like that with all the extensions. If that's all you have on your file system, that's going to be terrible performance. But if it's if you can provision IOPS for that or put it on a file system that has other code, like all of our images, 150 gigabytes worth or whatever is on a file system with that. Okay, maybe I can put it on the same file system and leverage the performance gained by that code, or so there may be multiple approaches to that. But again, you do have security versus performance versus complexity and so forth.
Okay. Well, we've got 10 minutes before the next talk, and I skipped our last break, so I'll give a few minutes of awkward silence just to see if anybody has any last words to say or any last comments. Okay, I think that's probably enough awkward silence. Awesome. So I want to thank you all for being here today. This is great. I've been, wanting to do this for quite a while. And, I'm sorry, Jeff was saying something. Did we cover Rich's question? Which question was Rich's question?
He was asking if there's a page on MediaWiki.org that covers all the resources that were shown today and other stuff around MediaWiki and Docker, which I think the answer to that, I think, is no. And if it's yes, I just didn't find it. So you can blame now our search cluster in that case.
Yeah. Well, it sounds like we could have as an action item creating a place. Yeah, and I am planning to put the Etherpad somewhere. And I'll put a link back to wherever it winds up on the conference page. Yeah. Okay. Thank you all. This was awesome. I really appreciate everybody's participation. And I will see you back here, I guess, in a few minutes for Daniel's talk.